Okay, I guess we're ready to start with our final course project presentation. And do we have the first speakers?
Yeah.
Polina?
No. Like they said that they won't present today, so the team about the mood of the nation, we would like to go first.
They are not going to present anything at all?
I'm not sure, but I'm certain that they won't be the first today, definitely.
Okay, so mood of the nation. Svetlana, Anton.
Yep.
Welcome.
Yep. Okay, hello to everyone. Today we're going to present our final project, Mood of the Nation during ongoing crisis via social media networks analysis. And I would like to highlight one more time the idea of the project and the reasons why we have decided to investigate this topic. Primarily, we need to mention that we are extremely interested to understand what is going on since 24th of February. So we are going to analyze mentions in social media related to Russian language or Russian or not defined location that contain any information related to the mood of nation in this period. It was 1 month since the special military operation has started. So as we understand, the regular life of people has changed. So the first month was really stressful and uncertain. So it is interesting point to focus on and have a deep dive. Please go on. So the goal of our project is to analyze natural language of mentions that we have collected and try to understand the key topics of discussion, sentiment, some interesting content related to our topic. And as a result, we expect to find these topics and somehow visualize them. So we're going to prepare a search query, then to scrape and prepare data that will help us to process the data later, analyze that, and finally visualize our result. So we just done short deep dive into some sociological concepts of investigation of social media. And unfortunately, we forgot to prepare English definition. I hope it is okay, and majority of people will understand what does it mean.
Is it your definition?
It is authors, like our group's definition,
okay.
Which was prepared after processing different concepts of social media analysis, like concepts related to concepts related to comparing social media and social networks, concepts comparing social media as a new reality when people can change limits in terms of location, in terms of time, and also in terms of social hierarchy and so on and so forth, and the concepts related to social media as new communication source. So as a result of all these concepts, we have our author's interpretation of what social media is. Please go on. So, okay, thank you. So we scraped the data. You can see here search query that was related to different definitions related to the mood. And also we combined Russia plus no defined filter within Russian language that somehow allowed us to collect data used with which VPN was used due to meta problems in Russia. Please go on. And we did not use any additional filters such as post, comments, or repost limitation, or a particular type of social media limitation as social networks or blogs or some stuff like that. Here you just can see pivot table related to all possible indicators that are allowed us for further analysis that you can provide us. We used mainly general indicators and tagged one. So please go on. And as a result, here you can see what we have done during primary data procession. We added some stop words that allowed us to eliminate some unnecessary topics that was irrelevant for our topic modeling. And also we used a merge duplication function that allows us to limit our database by 38%. And as a result, we have 618,000 mentions.
Oh, okay. So I've seen, sorry, Sweta, I've seen that we don't have much time left. Let me go straight to the data analysis and what we did in terms of texts. So the USCAN web scraping provides API to extract the top subjects which are covered in the posts. So the database that we had contained posts by different people, which we can analyze by themselves, or additionally use the pre-labeled subjects and topics which are found in the posts. So we took just the most important that we wanted to study, like health, war, economics, science, and politics. Like every other, like sport or cars, they had much less occurrences in the database. And the one that might be comparable to these 5 topics is children, but is unrelated, so we didn't look at this. But what is interesting during the first phase, we wanted to see if there are any clusters of opinions based on these topics that are already pre-labeled. So we constructed text embeddings with natural language processing from the posts that we scraped and somehow projected into 2D space to see if there are any clusters. And even so, the topics are kind of close to each other. We can clearly see that there is some separation, but the overall structure that these clusters are highly mixed with each other might be the consequence of the procedure of the scraping. Like we used specific keywords which might have general overall like bad implication on the text. So that is why all the posts that we have, they are very close to each other. But what is about the connection between these posts? Unfortunately, we didn't have many mentions. Like when there is a post by somebody, we didn't find enough mentions from the authors of these posts of other people in our database, so we couldn't construct a graph like from person to person on mentions and connections in the social media. So to see if there is some hierarchy in terms of language, we also looked at the edge banding of the graph that was constructed to visualize embeddings. That it just proves that there is a deep connection in terms of language between all the posts. But we also tried to connect posts which relate to the same subject. Like if we have 10 posts which cover economics, then they are connected by an edge in the graph. Unfortunately, this graph is very, very dense. So we had to omit like sample a small subsample from our data. And even on 10,000 nodes, we had like 5 million edges, and it wasn't a good idea to visualize this. So we constructed graph embeddings with node2vec using the L2 distance between text embeddings of the posts as weights for the graph. And then with node2vec, we visualized the new graph embeddings. But in this setup, we didn't find any particular graph structure. Like we expected to have clearly separated clusters in terms of graph connection, but unfortunately, all the topics, they are just completely random in comparison to each other, like their locations. So we hypothesized that this type of connection between between posts in our data isn't the most clever one. So we should have probably get data and craft it somehow specifically to construct these connections. But unfortunately, we didn't have enough resources and access to the data to do this. So from the point of view of semantics and text meanings, we have seen that there is some clustering, but from the point of view of connections that we hypothesized there was, so no particular cluster, unfortunately. So as a conclusion, all what we did, we scraped the data based on keywords, look at some basic statistics of what people think and talk about on the social media in our sample. And then we created some text embeddings and tried to visualize a graph of connections to see what kind of structure there is in our data. So that's it.
Can you jump back to the keywords that you used for searching? Yeah. So you do not have any keywords about military operation here.
I'm not quite sure, but the thing is that there is some kind of law restriction, so the people might not use some specific terms like military operation or war.
Okay.
Or if they use them, then their opinions might be very biased. No.
No. The idea was that we didn't aim to collect data primarily related to war, because our theme isn't connected to war or special military operation. It was connected to the mood of nation during ongoing crisis. So we're interested to understand what are people discuss related to the mood during this period, but not directly related to the special military operation. So we just wanted to understand which key topics are, okay.
Okay, so once again, your key hypothesis of the research is to understand what are the key topics people are talking about during this period.
How they are connected to each other, if there is any separation based on these key topics. Like, for example, themes like economics and politics are quite connected, but we don't know the...
But are you sure that they are connected because this is such a strange period of time, or they are connected because politics and economics are always connected to everything? Is it the feature of this period, or this is just the pattern for these topics?
So I think that generally these two topics are connected, but for example, as I see it, in some particular situations, the connection, like they might be just like almost in the same cluster if the general mood is the same in posts covering both topics, or maybe this overlap might not be that big in some other situation.
It seems
so I
like
guess you need to prove this, because this
yeah,
is still your opinion. I'm sorry, we're out of time. I had 3 more questions, but I guess I'll have to skip them. If you like, we can discuss the framing of your research in detail to the consulting hours, but right now, so we're out of time.
Okay, yeah.
We need to move to the next speaker. Thank you.
Thank you. Thank you.
Thank you.
Okay, and the next one, I guess we can jump back to our schedule and talk about the. Christina, are you ready?
Yes.
Okay, so the floor is yours.
Hello to everyone. My research is communication structure within the ODS community, and ODS is a workspace which contain a lot of users from many areas of IT, and this community is interested.
Christina, I'm extremely sorry for interruption. Just a few advices. I should have told it earlier, but I guess it will be useful. So if you have excellent grades for the first steps of your research, generally you can just quickly mention that you're doing this and this is what happened. It's better to spend time on answering the questions that you received as feedback to your course papers, and weak parts of your current research, places where you have bad grades. So it will let us all to understand what was done after the second course control point. Thank you.
Okay, and the main idea of my research is to create something like system that would rank experts, for example, some future questions according to their competencies of experts. The data I have a dump from Slack, and it contains messages from March 2015 to January this year. And then I sorry?
Continue.
And I decided to take into account 5 channels about computer vision, deep learning, Kaggle crackers, about Python and NLP. And then I decided to rank my experts with positive reactions. It's like emoji for each message, and I decided take into account positive reactions. Some you can see which one, and then I sum all this reaction for each users for each user, and normalize it. Normalize sum of this emoji, yeah, and use it like a target. Then I decided to take messages from each user in each channel and calculate correlation metrics, and it would be great to take some threshold to make our metrics more sparse. And I decided to take a threshold 0.9 and draw a graph with this matrix. You can see it. And I decided to train my GAT for ranking of experts, and to train and this model would in the future would predict ranked experts for some another users from another channels, and we can obtain expert rank level for another users. And I use GAT model with stellar graph library, and node features for each node was the number of messages in each channel. And I decided to divide the expertise into 5 categories. 0 corresponds to the lowest level and 4 to the highest. And you can see the parameters of GAT. But it's hard to say, but accuracy of my model was low. It's about 0.30, and I have some thoughts about why my model is so bad, and I have some ideas how to improve it, but I will talk it later. And you can see the and then when I train GAT, I can calculate the embeddings with predict function, and you can see the result of GAT embeddings for my data set, and you can see that it there are 5 clusters, and unfortunately some each cluster contain various number of experts with not one level, and I think and that's why it's because of low accuracy. And
Christina, does this structure correlates with the topic where those people are participating in? It looks like the picture that you observe just describes if someone, maybe this visualization just gives you an idea who is the participant of the topic about NLP and who is the participant of the topic about
Yes, I agree that maybe yes, I was wrong. It corresponds to channels and participations in these channels.
Okay.
And I decided to compare my GAT model with the baseline model. I took a random forest classifier, and I use as features levels corresponds to values corresponds to degree for each node, closeness, and page rank. And unfortunately, the accuracy is low too. And my considerations about low accuracy is that maybe I use wrong features for each node in GAT, and maybe it would be better to take into account another feature, such as maybe I would have been used NLP models to как вот рассчитать настроение сообщений.
Yeah, we got it.
Yes, mood of messages, and maybe I will take into account words such as спасибо and other positive words, and maybe my model will be better.
Okay. So generally, so this we had several talks about your project, and I guess the main problem here is that your target function that we decided to use is not just the best description of it's not the best measure if an expert is a real expert or not. It was just first attempt. Let's see if we'll take those likes and see what will happen. And generally, maybe we should have just had a look through the users that had this high level class, yeah, and try to understand what's happening in behind, because usually you know all those guys, and you can easily say if he's an expert or not. So maybe we should think more about the resulting target function and about the features. These are the first two ideas. The second idea about this project is that maybe, yeah, more accurate text filtering will be also useful, and it's quite obvious that different threads, different channels have different activity inside. So maybe we should have some standardized activity, because if you have 5 likes in the SNA channel, you're just the god of SNA. But if you have, I don't know, 50 likes inside the jobs channel or wherever it is, so some people have just seen your text. Yeah, that's the idea. So, and maybe some more work on feature extraction can be done here. But so we are not penalizing for bad results here. We're penalizing for bad using of algorithms, and generally, so the algorithms were quite correct, and your project was also good. So I have very positive feedback about this research.
Well, thank you.
Okay, so we have 1 minute for questions from just the audience. If someone is interested in something and wants to ask something. And in fact, guys, it would be great if you also participate in this discussion. So just join me. If no, I guess we can continue with the United Nations voting coalitions. So Yuri and
Good day.
Timmy. Yeah, hello. You're welcome.
Let me turn on the screen. Good. So the subject of our project was analysis of voting coalitions in United Nations. There are, I believe, multiple ways to approach this, but ultimately I chose to build a module that would process the computed graph of correlations, the one akin to one I provided in previous control point. And build a model that would clear up this graph so that existing community detection algorithm will work preferably better. Admittedly, the choice of the model became a problem and ultimately ended up using the following model. Where for each vertex in a graph, I tried to compute a distribution of how likely the given node is to be in a given block. With the conditions that the nodes within the same block are not watching partners. The justification for this counterintuitive approach is that if I attempted to compute the actual blocks, it would constantly fall into local minima, where I cannot assign to any vertex any given block, for the distribution is uniform. As such, I chose a process of designing nodes that will not be part of the same block, and then using it to clean up the graph. The module is smooth piecewise linear function that attempts to minimize the expected value of correlation. As far as implementation it goes, first, I have a separate module that collects the data using first queries to digital library for searching the votes during a given year, and then scrubbing each of the recs for votes. And then I fed the computed matrix into a small procedure that computes correlations. And such first use these correlations to build a watching graph, and then fed both the graph and the matrix into my model for cleanup. The model, admittedly, after a while, computes these blocks of cost enemies, and I use this result to filter the graph by simply removing the edges for nodes between blocks. First, I wanted to make sure that I don't accidentally break the blocks I know a priori exist, and as such used a cold war dataset for votes from 1965 to 1980. The result was that ultimately it didn't break the existing blocks, but altered a handful of them. One of the best results I noticed was putting island nations together with other island nations in voting patterns. And during visualization, I found out that the model has an unexpected effect of making the complete graph look slightly more appealing. To the left, we have a row graph where we remove every edge below a certain weight. And to the right, it's a process graph with the same filter on edges. In spite of clearly having less edges, the blocks that are present in the original graph are intact.
Generally, it's hard to map those visualizations because
the
you have
adaptation
different
is messed up.
coordinates of nodes. It's really hard to understand what is where.
Oh, I'm personally mapped in by the weight of related edges because they are the same between two graphs.
Yeah, also I can add that different blocks has different colored nodes, but
it's not very clear, yeah.
Yeah, it will be visible if you zoom in the picture, so you can see which block is which.
Okay.
After making sure that at least my model doesn't break things, I return to the dataset I cared about, the modern one. Empirical execution showed me that in result, the communities detected are largely the same, but in process graph, they found identifications not present in the region, namely between Russia and Belarus. Anyhow, the in row graph community detection algorithms to put them in the same community, or put them in a handful of other countries. However, in process graph, Russia and Belarus form a separate voting block, which is explicitly different. And the same applies to a block of Armenia Kazakhstan, which I didn't know even makes sense. Visually, it looks the same, albeit due to modern times, the graph is slightly less readable than its previous one.
Yeah, I can add that unexpectedly, we hope maybe we thought that it was obvious that there would be more blocks in the modern world, and during the Cold War period, that by our original thought, by my at last, there would be like less blocks and more blocks today, but it wasn't true. So it may show some unition, but it's not for us to think about that. Thank you.
In conclusion, I can say that model does have an effect, but it ended up being too computationally expensive. In particular, computing any of the process graphs took me about 10 minutes on my laptop, which I believe is very slow result.
Yeah, it's pretty slow result, but it couldn't be faster, I think, at least with these algorithms, because we can cut off the edges with low weight only after that procedure, and the computation must be done with all the nodes and edges present.
No, it has to do with the way descent algorithm works. Namely, I had to deliberately make provided gradient significantly larger than it should be to avoid falling into local minimum constantly. That's I believe all. Any questions?
Okay, so generally, so you're penalizing some edges for going outside the community, but maybe we can give some rewards for positive edges, and in this case, make this model kind of more stable. Yeah, because just decreasing the edge weight is not the only strategy. You can do both things simultaneously. And generally, it's in some cases is similar to influence propagation, because so first of all, obviously, there are some influencer countries and other countries that join them and form blocks because just the seed countries are influenced.
Yes, it happens.
Yeah? So I was thinking if we can adopt this model and maybe this data set to the influence propagation problem, because as I remember, the United Nations data set, there is the country that brings some document or multiple of them. Yeah, they can prepare this document in some collaboration, and countries who vote to accept or to decline this document. Yeah, so and we can say that countries that originally brought this document are some kind of seed nodes, and those who accept this document are kind of followers. Yeah, and model some influence propagation with using negative sampling for those countries who didn't like some votings. These are just some ideas where what can be done to see the same blocks with some different structure. Yeah, but generally, so yeah, one more important highlight. Just because I have worked with this data, there are different United Nations committees.
I believe I'm,
and
excuse
yeah.
me, I believe I'm interested. I just considered the General Assembly.
Yeah, but yeah, that's great. I forgot, maybe I haven't listened very attentively, but yeah, that's the correct decision. Otherwise, it's very hard to understand what's happening because most countries are outside those small councils.
Yes, exactly.
Okay.
That's why I don't consider the General Assembly.
Okay, great. So any other questions? So my main idea here is that, so maybe your presentation in terms of visualizing those countries can be a bit easier for the reader. So if you freeze coordinates on all your visualizations next time, it would be much easier to understand what has changed, because otherwise you need to transform this network in your mind, and it's a bit hard. But all the rest seems very nice and looks like a nice case of network analysis here.
Thank you for the feedback.
Okay. So yeah, the same idea. So if you would like to continue with some ideas of influence propagation, maybe so just write me a message. Okay.
Thanks.
And one more idea is that maybe you should talk to some politologists here and discuss what you observe with some guy that is focused on these international relations, and he will see some insights from Armenia connected to Kazakhstan. Maybe it's not a mistake, maybe it's a feature.
Yes, thanks.
Okay. So I guess we can move on, and the next talk is about the propagation of the COVID conspiracy theories.
Yes, one moment. So do you see my screen?
Yes.
Yes, so the main topic, the main idea of our project was the propagation of COVID-19 conspiracy theories on social media, I mean, Vkontakte. So this is our participants and members of our group. Then you can see some links, so on. This is our project collab. This is the main idea of our project, and in our project now we was trying to investigate the propagation conspiracy theories from the users to users and something like that. This is some kind of our hypothesis, and of course the link to detailed proposal. I guess that we can move on. So this is some kind of our plan and steps, and we still have done almost everything except all these parts, because we have some problems with our in codes like in our clusters, and we haven't unfortunately connect our clusters with our the final graph, but I will show it later. So, but partly, yes, we have done almost visualization as well. So this is some kind of data description that we have collected from the service Medialogia, the number of messages and so on, so on. So I can I think that they can skip. This is some descriptive statistics in Excel, but I think that we can also skip it. Yes, then we, after web scraping from Contacte, we have uploaded maybe some 2,500 messages, and only from 20 anti-vaxxers group, because the access to our subscribers was not we didn't have the access to them. So by the way, we have uploaded all users from our 20 groups, all groups of our users, and one of the most interesting part is cross groups of our users, like their interests. So Richard.
Okay, so I'll continue with this part. So we tried to perform some analysis using Python, and with the data that we had, we tried to find the diameter of the group. I mean the group-to-group message shared, and then the user group message shared. So firstly, finding the diameter, we realized that the maximum distance between the nodes of the messages shared was 5, and then the average of the cluster was 0.154 to that figure that can be seen there. So this is for the users in Python. So this was a brief analysis, and this was what we had. And we also performed a histogram. So you can see a histogram. So you can see the histogram for the groups, and for the histogram of the group, it shows us about the spread of messages, where all the messages were spread, and we can see from the histogram that all the messages were skewed to one part, meaning some group of people were really interested in sharing their conspiracies, and not all of them were really interested in sharing the conspiracies. So with the group to group, we had a diameter of 6, and then the average clustering was what we had, 0.1144, and so on and so forth. Okay, you can move on.
I'm sorry, but I thought you have only 20 groups. No?
Yes.
Or these are groups of people who took part in sharing information.
Yeah. Yes, these are just the group number of people who took part in sharing of information. Yeah.
Okay.
All right. So this is just a brief summary of the descriptive statistics. So with the subscription, as I said earlier on, the graph was telling us that the number of subscribers increased, and there is also an increase in messages sent between individual and the user group subscribers. So the number of it's increased, and then we try to add something new. We use the Barabasi graph network, and it tells us, the idea tells us that the number of nodes increases with time, and the messages regarding the spread of conspiracy theories. So it also tells us that the more connected of the node of messages are sent, and it means there is more likely that more people are, it tells us that more people are likely to receive messages, and then it also increases the likelihood that the people are going to share more of the conspiracy theories. Yeah. So move to the next one. And then, as I said from the previous slide, the histogram plot represents the data in the groups, and it shows us that the spread of the messages were skewed to the right part of the groups and the subscribers. And it also helps us to notice that the unusual observation, which means that probably not all users and the subscribers were interested in spreading the conspiracies. So it means not all the people regarding, let's say, the subscribers were interested in spreading the conspiracy. It means some people could be spreading and some people were not interested. So that was what the plot was telling us. So probably next one.
So then, yes, we just try to visualize our connections for group and groups, users to users, and to count their density and so on. But we came up with the idea that it makes no sense to analyze the groups because their influence is critically small compared to users. That's why we skipped this part of graph group to group. So then we use coefficient of Jacquard, this point, this amount, and then try to visualize the threshold in this point in order to get the strongest connections between users and users. So this is the idea of this graph. Then we try to visualize, again, the strongest connections, users and users, and we have got this kind of graph. So, and this is the list of new clusters, but as I said before, unfortunately, we were unable to combine our message clusters with the SIR model due to some issues. But this is the idea of the clusters of our messages. And this is some kind of SIR model. We really tried to do our best, and this graph illustrates the connections after defining the threshold criteria, as I said before, and it illustrates the users with the most intense connections, and this is 1% of strongest connections of all connections of this model. So, and this is SIR model of our propagation theories, and the main idea of this just it changes in time. So, and the main conclusions that we have done, that the hypothesis of the decentralized distribution conspiracy theories turns out to be true, seen on the model of propagation. And unfortunately, we have not tested the idea of snowballing propagation, but maybe we will do it later. And the clusterization shows us the directions of discussions in our groups, so in our online communities, and this is the main idea. So thanks a lot. This is some specific literature, and yes, thanks a lot again.
Okay, so in fact, I have heard so much about this project, so I don't have any questions, and I can see that you have finally added some SIR models that is pretty good. Have you used the minimum threshold in this modeling? I mean, at our seminars, we had, no, I understood that you took 1% of the strongest edges, yeah.
Okay.
But during the modeling of the epidemics, have you used any any threshold so that if all nodes around the white one are already infected, then it should also be infected? So what are the parameters for this visualization?
Yes, if you don't mind, I will maybe show the
sure.
Because it will be better to understand. So the parameter of beta in our case was, oh my God, I just
no, down. It's
okay,
written
yes.
beta.
Yes, this is one, yes. I just tested different threshold in order to get some different results, but honestly, I just put gamma 0 because we
you are spreading not the infection but the trend.
Yes,
Yes.
And I just tried.
And the threshold, what is the threshold? Yeah. You have the config.addNode configuration threshold, but what's the value of the threshold? Just find it. Control F. No, Russian.
Oh, sorry, I can't.
I guess E. Yeah. And no, this is no. One more attempt. Okay, we will never learn it. Anyway, thank you. So the next step. So it looks like from one side you have done this network structure and you have filtered it, but the general idea here is to compare if your modeling maps with the real case. Yeah. So you observe how this fake. Okay, I don't know. Should I call it fake
Yes,
news
okay,
or
yeah,
fake rumors?
Okay.
Is spreading, and the question is if you can model this spread with for at least 10 or more. I don't remember how many clusters do you have there. Something like 10, yeah?
16 clusters.
Yeah, so if you can model those 16
Okay.
clusters with your model, and if it suits this information spreading strategies or not. So if nodes that have been modeled as activated are really activated, and if not, can you give some ideas why and what can be changed in the model so to make those models immune to this spreadings? For example, for instance, you can change this threshold and say that, okay, he will never be activated because, I don't know, because he's a scientist and he doesn't believe in those rumors. And this will make your model really strong and really useful. So I guess everything is okay with your research hypothesis, but sometimes you need to make some more actions to get the final result.
Of course, I understand it. Because
Okay.
Thank you again. Thank you for your decent comments.
They are not so decent, but yeah, okay. And we're out of time. So I have improved your mark with the interpretation of the results and the hypothesis validation, but it's still not maximum since the research is not fully over.
Sure.
Oh.
Okay, so okay, and we move on to the project with temporal graph neural networks and cryptocurrency data modeling.
Hello, can you see the screen?
Yep.
Okay, so graph neural networks are becoming more increasingly widespread, and the idea of our project is to use one of them, which is called STEM-GNN, to predict the prices of cryptocurrencies and later use them in the trading strategy. The merits of using this particular type of network is that because it captures both inter and intra-series correlations, which can be especially useful for prediction in the financial sphere, and also it automatically converts time series into the graph data structure, so we don't have to do any additional steps. A few words about how this network works. Overall, it's pretty complicated, but we outline the main modules here. First, it converts a matrix X, which is of dimensions n times t, where n is the number of time series and t is the number of time steps, into adjacency matrix W, and then it uses a pair of X and W in its second module, which is called STEM-GNN block. Basically, what is done here is that time series is converted into Fourier spectral basis, and then graph spectral convolution is applied, and it is said that the correlations are more apparent in this basis. And after that, the predictions of the time series are made. The data we use is taken from Kaggle. Actually, it is a data set with more than 400 cryptocurrency pairs at 1 minute resolution. However, many pairs are temporarily misaligned, which means that some cryptocurrencies appeared later, some earlier. So we have chosen the following 12 cryptocurrencies which are aligned in time between each other, and we have 95,000 observations, out of which we take 80% for training, 10 for validation, and 10 for testing. A few words about our trading strategy. We use pair trading strategy, which is often used with assets which have high correlation in price or are co-integrated. That is, the prices of such assets in the long term move similarly. In order to implement the strategy, we first need to calculate spread, which is the price of asset X minus price of asset U. And we also have 3 thresholds, alpha long for buying assets, alpha short for selling, and alpha exit for exiting the position. So how do we determine these thresholds? We take the validation data set and calculate the spread on it. And then we define certain percentiles of the distribution of the spread and use the lower values for alpha short and higher values for alpha long. And then we simulate the strategy, which I will describe later, and choose the thresholds which gives the best result, the most profit. The simulation of the strategy is done as follows. We take a time window of certain size, a moving window, and calculate spread in it. Then we pass it to the prediction model, and this model makes a one-step prediction. And then we use this prediction in order to calculate expected spread change. And if this change is less than the lowest threshold, alpha short, then we sell X and buy U. Otherwise, if it is higher than alpha long, then we sell U and invest in X. And then the portfolio is revalued based on the current prices. We obtain the following graph from the adjacency matrix W. As you can see, the correlation overall is not so high between cryptocurrencies. We can see that Bitcoin is the center, is the cryptocurrency mostly connected with other cryptocurrencies, and this could be assumed. It is quite reasonable to assume this. Mostly it is connected with cryptocurrencies ZEC and USD. It shows small correlation with ETC, EOS, and NEO, and all other cryptocurrency pairs have very low correlation. Overall, we train our model, and it achieves the following metrics on the validation data set. And then we apply minimum spanning tree and disparity filter to look at the backbone of the graph. So this the results of applying these techniques. Minimum spanning tree basically gives us 2 groups of cryptocurrencies, but the drawback of using this method is that it tends to oversimplify the graph structure. So we also use disparity filter, which doesn't suffer from this problem, and as we can see, it has more complex graph structure, and the weights, the highest weights are different, are given to different cryptocurrencies, and the cryptocurrencies indicated in the graph I showed in the previous slide. Now we go to the results. Based on this graph, we identify Bitcoin, SEC, and USD to be used for the following analysis because they have the highest correlation. And we form 3 pairs out of these 3 currencies and trade them as I described in the trading strategy. And as baseline model, we use a simple ARIMA 101 model, which is just the value regressed on its previous value with time lag and some noise. And we can see in the table below that STEAM-GNN actually underperforms in comparison with the simple model because it doesn't identify any profitable pairs, but ARIMA, for example, identifies Bitcoin ZEC and Bitcoin USD as profitable pairs. However, it is not so easy to apply in reality because it has some issues with the robust estimation of coefficients and it needs larger window size. Overall, we make a hypothesis that STEAM-GNN underperforms because it heavily relies on the correlation between time series, and in our case, the cryptocurrencies do not show any significant correlation.
In the light of satisfying results with the STEAM-GNN and also based on the feedback that we received during the control point 2, we decided to also conduct an additional case study of classical network analysis for the Russian stock market. The reasons for that are several. The first one is that we consider daily stock data of the Russian market because it can capture more fundamental properties compared to high frequency data that was used in the previous case study, the STEAM-GNN. And also based on the data that was collected, it ranges from 2010 to 2020 September. And as I said, it was collected on a daily basis. Next slide, please. The methodology is quite simple, but the results, the insights are quite interesting and show that graph-based approaches can be used for stock market analysis. So the methodology is the following. We use 30-day moving window to calculate the correlation metrics between around 100 stocks and convert it to the adjacency metrics. And then the adjacency metrics, so at each moving window, we have an adjacency metrics, and in other words, we can see the dynamics of the network. Hence, we can derive some topological features of network in time and use these features for classical, for example, classical machine learning algorithms. And in our work, we showed that these features are significant in generating better profit than classical time series approaches. Next slide. For example, here we can see two graphs. On the left, it is the graph of the Russian stock market filtered using minimum spanning tree 5 months prior to the coronavirus market crash, and we can see that there are some there is clustering, but the clustering is more how to say it, more diverse, more there are more clusters that are less connected with each other. While in the second graph, we can see that this graph is during the April 2020 market crash, the coronavirus crash, and we see that all the stocks are more centered and more concentrated in one big cluster, which is related to a well-known hypothesis that stocks during the crashes are more correlated. So this shows that graph-based methods are very useful for analyzing the correlation structure of daily stock data. Next slide. And as I said, we in our work we show that graph-based features allow generating better performance metrics compared to classical time series. For example, on the left graph, this shows the return on investment of our strategy that uses predictions based on graph-based features, and on the right we show a graph that uses classical time series methods. And that is it. Thank you for listening. Questions?
Okay, so in fact, just one idea, one question, and one recommendation. Yeah. So the question is, what is the big node at your second graph at the 11th slide? Just interested. Yeah. So the largest in the center.
This is this is some stock, some company. Are you interested in the name of that?
Yeah. Who is the
yeah,
central node here? Just really
sec.
interested.
Well, it is. One sec. Я не знаю этот тикер.
Okay, so anyway, I thought it would be something like Sberbank, but okay.
It is not Sberbank. It is quite interesting that this is not it is not like a popular stock. It is actually Len Energo.
Very strange.
I think this is because I don't know. It is a question of interpretability.
Okay. So yeah. One highlight that can be done in both of those strategies, the stock market and the cryptocurrency market. I'm not an economist or a trader, but you know, when you're working with some trends and time series data, it often happens that all your objects are growing together just because everything is fine and everything is growing. Yeah, that happens very often. But if the crisis happens, then depending on the sector of the crisis, on the strength of the company and so on, they start falling independently. And you have, if you try to analyze the correlation function just on the single period of time, this may be not safe because you get more kind of correlated trends when everything is growing, but you will find out that when crisis starts, they behave differently. So maybe it would be a good idea to split your trading data on economic growth and economic crisis periods and train different correlation matrices. So this is just the idea that can improve the model, but I'm not sure if there is a legitimatized theory behind it. So, but it would be really interesting to check if it improves the model. Okay. Have you got the idea?
Yeah. Thanks.
But you are not happy with it. The third point here is that I have. So the question is if this prediction can be computed quickly or not, because how long it will take to make the next prediction given some current timestamp. Because one of my students has tried to adopt several models to real trading algorithms, and he had a problem that neural network models took too much time to predict these correlation coefficients, and he needed some kind of more quick tools to do something. And in fact, I can just contact you with him, and you can maybe I don't know, join forces or just discuss both of those methods, yours and his, and see what will happen. Maybe it would be just interesting for you.
Yes, that would be cool.
Okay, so these are just main ideas about the feedback, but all the rest is pretty excellent, because so very good models, nice data, nice hypothesis, and I'm very happy that you haven't stopped at the control point 2 and added additional research here that made your final project even better. So that's great. Okay, thank you. And next one is the talk about some strategy of looking how to make bridges between natural language processing and social network analysis, how to find some sentiment important lexicon using social network analysis methods. And it's done by Victor, Ariel, and I guess Washi or Ahmed. Yeah, sorry. So you're welcome.
Okay, can you hear me properly?
Yeah.
Okay, so the title of this work is called Improving the Quality of a Product via Network Analysis and Natural Language Processing. So what we will do in here, so we took about 20,000 reviews from TripAdvisor, and well, the data set is only containing the review and its rating. And what we will do is to pre-process the reviews, and we will extract all meaningful data and trainable things. We will train and test a prediction model able to detect the sentiment, and then thanks to a social network analysis, we will be able to extract good features and bad features of the product. Then we will plug what we obtain into our model, into our predictor model, and we will know how accurate our investigation was. So, well, regarding the text pre-processing, this is somewhat what usually people do. So first we tokenized every review, then we delete the stop words and the alphanumeric symbols because, well, these are not providing a lot of meaningfulness. And then we stem the words. What is stemming the words? This is just taking the root of the word, because we don't want to have two very similar words representing two different nodes in the network. This is a waste of, for example, memory. Yes, and it can lead to some distractions. Then once we have done all the pre-processing, we created a vocabulary of unique words, and we ordered the words by its frequency. So I mean, the most frequent a word is, the lower index this word has in the dictionary. And well, this has several advantages that we also use. And well, then we create our data frame that we will pass into the model. So as you see, we have rows and columns. So every column is representing a word, and the rows are representing every review. And then the label to train the model will be the sentiment column. So sentiment 1, it means the review is positive, and sentiment 0, it means the review is negative. That's it. So that's the way reviews are encoded. Well, and regarding the model for sentiment, we created a PyTorch model, and this was just a fully connected artificial neural network, and it had 2 hidden layers, and we also included a dropout layer just for making sure that the model is not learning by heart. And the activation function, it was a ReLU function, so rectified linear unit activation function. And that's it. So we used 27 epochs, and we obtained 82% of accuracy over the reviews in the way we encoded them. And it just took 8 seconds to train the model. So this is quite nice. And well, the accuracy is on the test data, of course. Okay, then regarding the drawing of the networks, we had requirements to allow 2 nodes, so 2 words, 2 stem, whatever you want to call it, to be connected. So the first requirement, it was that they need to share at least 1 rated level. The second requirement is that they need to appear together in a minimum of reviews. This is just for segmenting the network. The third requirement is that they need to appear together in a maximum of reviews, just for the sake of segmenting the network again. And the last requirement is that they need to appear with the same frequency. So it means that the absolute value of the difference of their indexes in their dictionary should be less than a threshold. What else? Okay, and what's important here is that the assignation of colors is done sequentially. So a lot of words will be stacked in the first layer, then some others in the second layer, so with the second label, some others in the third layer, and not a lot of words, for example, in the fourth layer. And what we expect is that words in the fourth layer are those bringing the positivity, and also in the third layer. That's the idea. So it is some kind of filtering of what we are interested in. Regarding the statistics, so here, for example, we computed the degree centrality, and for example, the bigger a node is in here, it means that the greater the degree centrality is. This is the way we choose for representing it. Regarding eigenvector centrality, so for example, here you see that there are a few nodes with a high eigenvector centrality coefficient because they are like bigger. Between centrality, it is the same idea. There you can find the nodes with a higher between centrality coefficient. We also computed this analysis on connected components and so on. And for example, the words that have greater centralities are these ones. So regarding degree centrality, we have home, noise, expensive, huge, coffee, between is hard, huge. So yes, no surprise that, for example, expensive has a very high degree centrality in TripAdvisor reviews. So and for the negatively influential words, we do the same, but in an inverse process. So first we assign words with label 4, then words with label 3. So we do the inverse filtering process, and then we find the negative words. So also we wanted to see the difference with, for example, an algorithm like SHAP. And okay, I will comment later what we found. So, for example, from the network, we found words like Spanish, and then if we plug Spanish 100 times in our predictor model, we find that 86 out of them are positive. So, for example, if we plug near meal in our model, we find that 91 of the predictions are positive. And for example, things that we can think that they are important for example, extra feel or light, those were in a second layer or in a first layer. So our model is actually telling that this is not so significant for bringing positivity. And also, even more, if we plug words that are actually connected, so for example, definite and quiet, issue, right, or Spanish, specie, fresh, we obtained that 100 out of the 100 of predictions that we did were recognized as positive by the model. And also for the words that SHAP detected. Yes, so SHAP detected huge, SHAP detected enjoy, and we passed through the model, and the model is telling, okay, this is very good, this is bringing a lot of positivity. But our model was not able to collect these words, for example, because they were very general, and our model is collecting very specific features. And well, all the same applies for the inverse rating generated networks, so the inverse process. And well, if we want to check what is happening in general, we took all the words colored with pink, we took all the words colored with green from a lot of generated networks, we collected them in a list, and we passed through the model. And if you take any random word being in the pink list, for example, randomly you will obtain that 60 out of 100 times you plug this word into the model, it is recognized as positive. And we are plugging just one word. If we plug 2 words, then this coefficient increases. So it means that we kind of found something interesting with this. And actually, that's pretty that's pretty much it. We have some appendix, but I guess we are out of time, so it is already 5:25. So the appendix is only showing how varying the seed, the threshold 1 and the threshold 3, threshold 2 are.
You have 1 more minute. That's
okay. Okay. So if we vary the seed, we just obtain different configurations of the network. If we vary threshold 1, so this is the number of indexes that words can be distant between each other. We observe that if we increase threshold 1, then more nodes can appear. If we increase threshold 2, there will be less nodes in the network, because this is segmenting even more. And if we increase threshold 3, there will be more nodes because we segment the network less. So that's it for the appendix. And this is what we could take from the community detection part. So it can be understood as another appendix.
Okay, so is it done?
Yes.
So you already had all the comments, and from my point of view, the most important thing about this research is that the team really growth during it, because they started with just some words that they have detected and no idea what to do with them then. And they ended with a very nice, it still has lots of heuristics, but this may be a really useful tool for model interpretation, for example. And the great thing about it is that it works very, very quickly. Yeah, much quicker than SHAP and other methods, and still give you some interpretation of what is happening and the visual interpretation. And they have also analyzed how different parameters of their model affect the final visualization. And all this makes this very, very promising idea. So it started without any framing, without any understanding what we are doing, and ended with a very nice idea that can end as a good paper. So thank you very much.
Thank you. It was a pleasure.
Okay, guys. So subscription affiliation by Vera, Alexandra, and Vladislav. So
yeah.
are you ready?
Hello. Yes,
Hello.
we are ready. Sasha, are you here? Can you please share the presentation? I cannot see my colleagues here. Just 1 second, I already brought them.
Should we skip your talk and give you some time later?
Actually, we are ready. We just don't know where is Sasha. Sasha, where are you? She wrote my, she read my messages, and I think just a few seconds and she will be here.
Okay, then we're waiting for you.
Yes, she's here.
You make? Yeah.
Sasha, please share the presentation.
Sorry for technical issues. I guess we're ready to start. Sorry, I'm trying to share my screen, but
You can send me presentation, I will share. And Sasha, where are you?
yeah, I guess now it should work. Sorry. Vera, please stop screaming my name, actually. There's one.
We still cannot see, but we see that you. Oh yes, we see.
Yep, I guess you're supposed to. Okay, sorry for the delay. We're ready to start. Yeah, basically that's our final course project, and it's devoted to the impact of subscriptions on affiliation in different communities in social media. So let's talk a little bit more about it and what we've got here. So basically, this study is going to examine the influence of social media subscriptions, as I already said, and we used social network analysis and machine learning models for that. As for social network analysis, there are a lot of researches devoted to this topic, and the popularity is started to grow after emergence of online social network services. I think there is some logic in that. And basically, social network can be constructed from some relations data and can be defined as a set of social entities. And actually, it allows us some multiple types of relationships and how they operate, studied and see what's going on there. And basis for our research was VK social media. Right now in Russia, it's one of the most popular media platform, and it contains 28 million people that are registered here and more than 500,000 of communities, 500,000. And our hypothesis for this study is that social media subscriptions have a strong influence on the definition of the faculty in which the user studies at his university. So we decided to study the subscription of some users and see where it goes. So we defined some key building blocks that help us to test our hypothesis, and they can be defined as following. So it's basically the data, the model, and the features. And talking about the data or the data, whatever you like, about the description of the data, our data set contains some data about users and their subscriptions. The source for this was a Vkontakte, because we're analyzing this social network. And for data collecting, we used parsing. So about features, we've got here gender and group names. Both of them are Boolean, and for gender, 1 is a woman, 2 is a man, and for group names, 0 is not subscribed, and 1 is subscribed. Since we used Y type of data tables, our table contains about 413 features, so it's quite a lot. And for our analysis, we used 2 models, is decision tree classifier and XGBoost. And I guess Vladislav will tell us a bit more about it later while discussing how this models works. So Vera, I guess now it's your turn, and you can tell us a bit more about the statistics that we've got.
Yes, thank you. So in order to validate our hypothesis, we created a network, and for this network, nodes was users and age were user connection to the different groups. we made a small description statistic for our network, and we can say that there are approximately 7,000 nodes and approximately 12,000 edges. We can stress that our network is undirected. It means that edges do not have strict directions, and average degree of node is 4. That means that on average, each node connected to 4 nodes. Our density is lower than 1. That's why we say that our graph is really sparse. So let's move to centralities. The degree and between centralities are really small, but as for closeness centrality, it between 0.10 and 0.25 approximately. It means that the information quickly spreads in our network from one participant to rest participants. Next slide, please. That was all about descriptive statistics. Now let's speak about community detection. Why we need community detection? Actually, there are quite a lot of tendencies of people with similar tastes, choices, and maybe preferences. And usually these people are associated in different networks and maybe even in the similar networks. So we need to detect our communities in order to understand the structure of our network. For doing that, we created Euclidean distance matrix, which represents the spacing of set in Euclidean space. And based on Euclidean matrix, we created agglomerated clustering and DB scan. And based on that, we can well analyze the clusters we have in our networks. Actually, our clusters are overlapped because actually our clusters are overlapped because one member can be in different clusters. That's why they're overlapped. And the density in overlaps is high. As for clusters, we found 3 main clusters and others are supplementary. The first clusters are users who follow some HEC groups. The second cluster are users who follow some groups with funny pics, so they find some memes. And the third cluster is news groups. Let's move further.
So now we will talk about the model that we've built. We're using two. We have, as Sasha has already mentioned, we have trained 2 models: the decision tree classifier and the XJ boost classifier. We will further see that we have also used grid search cross-validation and randomized search cross-validation for hyperparameters tuning. But we decided to stick to the randomized search cross-validation hyperparameter tuning, since it's much faster and efficient. So how does this work? Grid search basically uses several folds k-fold cross-validation with all the possible hyperparameters combination that we pass to this method, while a randomized search just collects the sample of the hyperparameters range that we pass to the model, and thus randomized search is more efficient. But however, it might provide not the best model, since not all the hyperparameter combinations are used. So you here can see the code that we used in our model to build our models. Now we can move on to the next slide. We have used F1 score, macro F1 score for as a target metric. We see here you can see the best parameters of our models and the best scores of our models, which is macro F1 score. So what is this F1 score? It's basically the harmonic mean between precision and recall, and the macro F1 score is basically the average F1 score across all the classes that we had in our model. We built, since we have a lot of different classes, it's a multi-classification task, and thus we use this F1 score. Now we can move on further. By the way, I want to mention that we see that F1 score here is not very high. Its F1 score basically ranges from 0 to 1. And here we have the best model has 0.18 F1 score. Yeah, now we can move on to the next slide. Yeah, what's the insights we got? Since we had social communities in VK as features, we can see here the feature importance graph that identifies to what extent the different participation in group influences the prediction of the class of a person or the faculty of the person. So here we can see that there are some logical logic behind this feature importance graph. We see that at the top there are quite a few groups that are somehow related to the specific fields of studying, such as International Institute of Economics and Finance. It has the hugest feature importance. Also the math groups, which also can identify what group, help to identify what group a person belongs to. But we also have here some groups which are basically meme groups that are not bound to any specific, that can be used to specify what is the faculty of a person. So now we can move on to the next slide, which is the conclusion. We see that our hypothesis is not validated, basically because we don't see quite high metrics of F1 score in our model, probably because it's because Vkontakte is used not for in most cases Vkontakte is not used as a mean to acquire some specialized knowledge, and is basically something that is used for having some fun time and recreational activities. Thus, people might not have a specific profile which of groups which is used, which can basically indicate the faculty or interest to which a person belongs to. So basically, that's it. Thank you for your attention. If you have any questions, we will be glad to answer them.
Okay, so generally we almost don't have time for questions. I guess there are three main ideas how to improve this research. So the first one is that am I right that the connections between your nodes are just friendship ties? Yeah.
Friendship? What
Yeah.
did? No, the connection is membership
in different communities. Yep.
Sorry. When you're talking together, I cannot understand who's saying what. Can you please repeat it?
The connection is connection to the group, connection user to the group. So if the users connect to one group, so they have connection.
And if they're connected to 5 groups?
There will be, it's basically a file, or the data is organized as a file where each row represents a person, each unique ID, and each column stands for all the groups that we have in our sample.
Okay, jump back to the, I don't know, very first slide. Can you please do it?
Yep, sure.
Okay. Any picture with your graph, or yeah, this one. Yeah. So what is the node here, the green one?
The green one is news groups, users who are involved in news groups. Users
who are involved in users groups or news groups.
Users, not news groups, users.
And what does the connection between 2 nodes here mean? Just that they have the same group and they share the same group?
Yes.
And do you normalize those connectivity by the size of the group?
No. By the size of no.
Because we're all members of, I don't know, news groups and of Coca-Cola groups, and they have nothing special.
But there actually was specified groups, which we first of all downloaded data of HEC students, and for determined HEC students, we parsed data from HEC groups. So we parsed members of HEC groups, and then we of these members parsed their groups. So
have you excluded the HEC groups from the data set?
No, we didn't.
It seems that you looked for the things that you scraped, no?
No, because HEC group took the less percentage, because we just chose about approximately 8 HEC groups, and every user subscribes approximately for 30 groups, and it means that HEC groups took the really small share of groups, which.
But am I right that your target feature was based on the HEC group membership?
No, by our target feature was by. Vlad, can you help me, please?
What's the faculty to which students belong?
And where have you got the information about the faculty?
From the personal page information. There
okay, yeah, I got it. Now it's okay. Whew. Okay, we're out of time, but generally, the main question here, why haven't you tried to use something like, so first of all, it's clearly seen that you can generalize these features with any metrics factorization or community detection tool. So if these guys are interested in use, it doesn't, we don't care which exactly news group he's following, just take any. Yeah, so we can take this as some kind of aggregated feature, and this looks like something that can improve your final result in terms of generalization. Secondary, so we have models like GOT that can predict the variable given some features, and this task looks like a good task for graph attention networks, just something similar to the Christina's case, maybe. So the recommendation here is to try to use it. Okay, we're out of time, and if you want to talk about the continuation, just use the consulting table. So if you're interested in it, and we're going to the next talk, and Polina and Artem, you're welcome.
Thank you, Professor.
Yeah, hi. Let me share my screen. Okay, can you see it?
Yeah,
yes.
Perfect.
Okay, nice.
Okay, let's start.
So today we want to present final version of our project. For the previous checkpoint, we got some data from RIA News and to build graph with person who used to be in the same articles. So as a final goal, we decided to implement a news recommendation system. First, I want to present main point of our project. So we want to analyze news articles. We have several goals. Firstly, we wanted to identify groups of people who often appear together in articles and build a graph on it. And secondly, we want to implement some recommendation system based on build graph. Next slide. We collected data from RIA News for 5 categories. You can see it at the slide. For our final experiments, we used only 50 articles in each category by the reason of really long time articles processing on CPU, but it looks enough to build person's graph. Next slide. For person's recognition in articles, we should use model for name entity recognition. But also we wanted to make some linking between person's name in different forms. So it's called entity linking task. We solved it with deep-power library. On the slide, you can see algorithm pipeline. The main idea is to do named entity recognition, and after that, make mapping person's name to wiki page we found human. By this, we get common form for different persons' names. Next slide. There is some example of entity linking article processing as an output algorithm return code from wiki for recognizing person. So this way we were able to extract the names of people from article in general form. And now Artyom will talk about building a graph and using it for the recommendation algorithm.
Yeah, thank you. As Polina already mentioned, our main topic to analyze is person interactions. And the first thing that we did is graph of joint mentions. So in this graph, vertices are represented as so persons. So vertices are persons, and edge weight number of joint mentions. Joint mentions means that how many times two persons were met in one article, or not one, in any articles. And on the right side of this slide, you can see the example of one large connected component of this graph. As you can see, it related to politic topic. Yeah, also we collected some base statistics. So it is not used for further recommendation algorithms, but it was so useful to for us to analyze how many machine learning processing we can use on such small graph. So that I can say. And the next slide is about our applyment of topic analysis. So we suggest to create some recommendation algorithm. So task is in suggestion for each article some complementary articles, and here the pipeline of recommendation algorithm. First one is articles. So assuming that we have already articles and persons included in these articles from parts of entity recognition, However, we should do another article preprocessing. Here, a small part of this preprocessing, main parts is noise sentences removal and tokenization and stop for words removal. Next is main part is the usage of word-to-vec model. Any article is transformed into embedding, and with world movers distance, we compute similarity measure. So similarity measure is a fraction of 1 on 1 plus this distance. So we get similarity of any two articles. And the last part of this subsection is to get top k by the similarity in descending order. The last part is main by idea, but not so important in terms of algorithm results. It is re-ranking articles with our person entities relations. As we already built our graph with co-occurrences, we compute several centralities coefficients and compute one important score per each person as some linear combination of computed previously centralities. And on the next step, we assign each article its own importance score as an average importance of participated persons. So average is required here as some articles conclude or contain many persons, while others only 1 or 2. And after importance score, we did re-ranking, and our algorithm has the final result after this re-ranking. About evaluation, as we used the dataset without any kind of user event stream, the only option to evaluate our results is our own like a human eye assessment. We used 10 articles and suggestions for those articles, and mean average precision is so it's at 3 it's quite normal for such task. It means that 1 per 3 is so imagine if you read some news site and with probability of 40%, we can read some complementary recommendations. If we consider 3 articles, 1 of 3 expected to be read. While if we consider a 10, it's extremely low, but it is normal. And it should be also mentioned that our project and this algorithm is not a full pipeline proposal of recommendation system. It's a small part which should be and must be combined with other parts of data processing. So it's kind of feature engineering. Yeah, that is the last slide. Yeah, our examples of recommendation. The first one is about politics example. So for example, the source article which used to generate our recommendation is So let me not read it, just check. Polina, you can add some words if you want.
I think that's all.
Mhm.
We are ready to answer questions.
Thank you.
So in
Thank you.
fact, I guess you have seen the questions at your email, and can you please highlight them? The first question: why have you focused only on 250 papers or something like this? Yeah, because it's an enormously small data set, and so predicting the good recommendation given 200 papers has one score, and having, I don't know, 2,000 papers will give you just very different score, just because you have much more examples that you need to pick within. The second question is, can we compare your current result on this approach with some baseline strategy? For example, pick just the document the closest in terms of just pack of words, and see if it will be worse or better in this case.
Okay.
Yes. Sorry, and one more question from the email. Have you tried just making the same prediction without the page rank that you have incorporated inside your score?
Okay, let's start from first question about small size of data set. The reason about this is really long time processing on CPU of each articles and extracting name entity. So by this reason, we should use a small subset of our data set.
Okay.
So there was one more question about why we use only persons named entity. We experiment with different names. There is locations and
in fact, there is one more question. Why you need to link them to Wikipedia? Maybe just having some persons is enough?
It's common process. I just find it, and it's works really good.
No. Named entity recognition part is okay, but what about the entity linking? Why do we need it? Because there are lots of entities that are absent at Wikipedia, for example, and you can add some mistakes at this step. So do you really need an entity linking step for your method?
I think yes, because we build graph on it, and there is names on different forms. For example, in this text, you can see Oleg Artemyev, and later there is just Artemyev. So we need some common form on these person names. So it needs entity linking task.
Okay, so the final question is, how can you compare your current research with any baselines?
Yeah, our baseline, so the main idea was here is look at step 2, find top K similar articles. So it's kind of baseline by word-to-vec model. So we use simplest words embeddings and use this also one of the simplest distances to calculate, measure, or similarity.
Yeah, and what's the result for this work-back model?
Yeah, it wasn't evaluated due to our own human resources, but in terms of our development process, it was improved. So we get, for example, in politics, many articles are very close, but some of them are not so important. And the main idea was here is about, as you can see, we re-rank a small part. So we generate only part of so at the second step, we generate only one part of our recommendations, and those recommendations are re-ranked due to their importance. So in terms of evaluation, only ranking metrics will be changed. What should be first, second, and
okay, I got it. Sorry.
And about PageRank, it was a nice question. It was improved since mail and degree and other centralities were computed and used as linear combinations. Also, I checked some papers about centralities usage in link prediction, and surprisingly, degree centrality is the most powerful coefficient for such task. So PageRank and degree centralities were used with higher coefficients in linear combination.
Okay, thank you. And sorry, but we are already for timing for pretty much time. So next talk is about the politician's image building the mentions network. Luckily, it's very close to the previous research because so we will also see some entities on the graph there. Victoria, you're welcome.
Yeah, thank you, Professor. I'm gonna demonstrate my screen. Do you see it?
Yes, we can see it.
Good. So we start. The topic is assessing of politicians' image and building the mentions network. About the project. Firstly, politician's image is a key point to understand how effectively an electoral campaign is organized and what chances a winning are. So it's important for politicians, especially for the governor. Social networks allow us to identify whether the electorate is loyal or not. So we can see mentions and in general the attitude of to the politician. We research the dynamics and connections of its mentions in social networks based on the Russian governor Igor Artamonov. Thanks to the CNA method, we were able to determine the components of the image of a politician and the citizens' attitudes to regional authority. So the goal of the project is the purpose of the study is to test the functionality of network analysis to assess the public image of a politician.
Well, as for the steps of our research, firstly, we collected data. Our data is textual. It's especially comments on in the social networks Vkontakte and Instagram. These social networks were chosen as the most popular in Russia, and because of the case, as particularly this governor has personal accounts in both networks. The first step, we built a network and did our best to interpret the results of our analysis. As for the data description, as I've already said, it's textual data, and more than that, we have some like data about the authors of these comments. We have gender data for like 50% and age and like some data of marital status. It's mostly of these data are about of the users from Contact. Yes, Victoria.
Thank you. As for using CNA method, after uploading data, it will comments from automotive social networks. Using Medialogia service, we use the method of CNA to get information about the mentions and connection between them. Firstly, preparing for that, we use natural language processing for checking the most popular words and main topics. As a result, we got words connected with economics. There were Gref and Sberbank. And secondly, words connected with Union Russia Party, for example, incumbent, UR, United Russia. And secondly, Artemonov's political activity. For example, words help, roads, children, gardens, and others. Generally, it can be divided into several subgroups of mentions. Firstly, it's economics. Secondly, it's political activity, and thirdly, social policy with positive feedback. And the next one is connection with the United Russia Party. So you can see the graph. We read the data from the Excel file into the pandas data frame to get a tabular representation of the comments and its engagement rate. So each line includes all the most popular words from search and comment. We have distributed the set so that each of them represents one popular word as a note between other comments with such words connected. Network description. The graph shows that there were several logical groups of keywords as we revealed by NLP method as an extra one, united by meaning, which are supposed to be the components of the politician's image. Some of the comments mentioning Artemonov touch upon his work at Sberbank. Residents of the region perceive the governor as a banker. This block should be considered as a significant element of Artemonov's image. In addition, another part of the users have a negative attitude towards Artemonov's belonging to United Russia. You can see it as a yellow colored block. So it's necessary to notice that connection with the ruling party causes distrust of the electorate. Users have a negative attitude to Artemonov's membership in United Russia and also poorly assess his electability. So the negative attitudes were revealed by reading and manual analysis of comments, because graph can't describe it as negative or positive. The next one, the comments mentioning Artemonov also touch upon such aspects of the governance activity as the regulation of prices and wages, including the high salaries of officials, healthcare, education, and transport, and also everything that includes social policy issues. As a group, what we have noticed already. Purple color cluster actually demonstrates rather negative block. Artemona raised prices for housing and communal services and didn't clean Lipetsk from snow and made inconsistent decisions regarding coronavirus restrictions and mass events. Made an unpopular decision on high fines for violating the mask regime. And the smallest block of graph appears in basic Artemonov's name. Variations including Artemon, Artemonov, and governor. You can see it as a pink colored cluster. As we noticed, every variation refers to its block of mentions. For example, Artemonov as the official one connected with the economic block, which is blue colored. Next one, Artemon as the more informal one, into the political policy block, which is green colored. Other detail of our analysis is social demographic characteristics that could show us more trends in our research.
The analysis of demographic characteristics of the authors of the comment made it possible to identify the following target audience for targeting materials. In political science, especially for the governor, it may be useful and like a kind of recommendation. More than that, it's their analysis of the authors. So in the slide, you may see like 7 themes and data about the audience. For example, as for coronavirus restrictions, we can see that about this topic talk predominantly middle-aged men and less women. As for example, improving of public services, also middle-aged men. But for example, as for the healthcare, we may see like equally men and women, and predominantly a large proportion of young women. And we got such data for everything. Could you please, Victoria, next slide? Well, to detail the tone of statements from the analyzed comments, a representative sample of about 900 random comments was made. Each of the sample comments was assigned to one of 4 categories. You may see these 4 categories in the table in the slide. And in general, compared to women, men treat the head of the region more negatively. Comments related to one of the 3 types of negative comments make up a total of more than 70% of comments left by men. As for the distribution of commentators by age group, we see that middle-aged people more often speak about him, while young people are less likely to leave comments about the governor on social networks. In case with users whose cities of residence about the cities, we see that about half of the comments are left by people who live in the capital of the region in Lipetsk, and like about 25 comments in another city of this region, much more small, Yelets. And there are another region, but the percentage is really small.
It's an interesting fact that in comparisons with users from the capital of the region, users from Yelets have a greater number of comments representing sharply negative and unconstructive statements about the leader.
About conclusion, firstly, the analysis of public person's image could give us an understanding of how it's presented in public opinion, especially in social networks. Secondly, the advantage of social networks analysis method is giving us an idea that about those aspects of the governance image that cannot be identified using a manual analysis of comments using parsing systems. For example, I mean, we can't see on graph which cluster is negative and which is positive. The next one is regarding Altamonov's case. We analyzed comments in all social networks and revealed that there are several clusters referring to economics, political activity, connection with the United Russia Party, social policy with the positive feedback in general. Thus, this method has proved its practical applicability. Based on the analysis, it is possible to give the governor recommendations on which areas to focus on while focusing on the target groups identified during the analysis.
Well, and this research may be really useful in real life, and based on these data, it's possible to build recommendations for the head of the region. For example, you may see such kind of recommendation on the slide. It's a recommendation about the focus and the strategic strategic actions for the leader, and these to our mind may be really used in real life. That's all that we wanted to say. Thank you for your attention.
Okay, 20 seconds for questions. Can you jump back to the graph with our Tamon structure? Yeah, the previous one. No. Yeah, thank you. So the colors of the nodes and edges were extracted manually, or there is some algorithm behind it still?
No, it was manually.
So your methodology is extremely correct and useful, as I have participated in several election campaigns, and people there are doing just the same thing that you have done. The best, the weak part of this research is the automation block, because lots of things here is done just based on your intuition. Yeah, and this is always bad, because you cannot use the methodology without the methodologist. Yeah, and that's the problem. And in fact, the best thing you can do is just to combine forces with the previous group that made the research on RIA Novosti, because they have made a lot of computational stuff, and you have made a lot of more kind of PR or politological interpretations. And if you combine forces, you can make an extremely good research or system. Yeah, it would be really cool. Just to extract the Verbank and Artamonov automatically and to put them on the graph using this linkage algorithm from Reuters, to extract the most important and some kind of sentiment labeled edges and highlight them as you have made it manually. It would be extremely cool. So this is a very good research and a nice portfolio case in terms of political person analysis. And as I told you, we really do make such kind of visualizations. Usually they have much more nodes because more data is taken into account. But the thing that you have done is very close to the industrial things that people are usually doing when they're analyzing someone's image. But there is a lot of work that can be done to automate this research, and it will benefit from it. Okay. So this is the main feedback, but still, it's very interesting.
Thank you. And may I ask you a question about the tests? Really small.
You can write it inside Telegram. I'll make just one quick announcement that they may be mistakes with your grades because I'm too lazy. I wrote an automatic script that maps your grade with your email, and sometimes so they may be mistakes. So if you're supposed that there is a mistake, just write me or take the consultation, and we will solve all those problems. Okay.
Okay. I will write you. Thank you very much.
Great. So the next speaker is Fedorov Igor and Shabalin Evgeny on household speaker recognition. Yeah, and guys, I will penalize you if you will be out of time. I will take some points from your presentation. Great if you will talk too long. Just please be careful.
Good evening. Me and Igor will tell you about our project, graph models for household speaker recognition. So as Igor told on the previous presentation, speaker recognition is a problem of recognizing who is talking in the audio. We have some audio sample and want to know which person it refers to. The household speaker recognition is a sub-problem of speaker recognition problem, and here we have a family of speakers. We know who they are, and we want to distinguish them from some unknown speakers. This is a very common task in clever houses, in clever devices. They want to be personalized for each person, because each person has thoughts, ideas, preferences, etc. As a data set, we used VoxLab 1 to be precise. It's an audiovisual data set. We don't need visual part of it, but it has a lot of speakers, a lot of speech, a lot of labels. So we sample known speakers from it and decide that everyone else, just random speakers, are guests or non-speakers. So we have some pre-trained speaker embedding neural network, and we can obtain from a sample of the audio, we can obtain embedding. And this speaker embedded model does not know anything about our relationships in our families. It can only calculate embeddings. We use some similarity metric. In our case, it's cosine similarity metric, to understand if two audio samples are close to each other. They embed, so we calculate the metric between these embeddings, and we have enrollment. This is like a lot of utterances for one speaker, like one the utterances of all utterances of one speaker are called enrollment. So we want to apply a graph to classify where speakers, and we do it in the following way. We treat every utterance as a node in our graph, and we calculate embeddings for it. So like every node is an embedding of some sample, and we use distance metric to calculate edges. So we have the metrics with the following weights. And now to our algorithm, we changed it from the previous presentation because we thought this is more suitable for our task. We calculate, we have some known speakers, and we want to initialize our graph. We do it in the following way. We calculate the centroids of our graph, where k is the number of utterances and x is the enrollment. So this enrollment of size k. So we calculate sum, and we can store not the embeddings of every utterances for speaker, but only the sum of them. And also we calculate thresholds. We will need them later to distinct speakers between each other. So now we have a graph. We have clusters and subclusters of it. Cluster is all utterances of one speaker, and a subcluster is a small cluster with close utterances. So, for example, we have like one large cluster for speaker, and we have like 10 classes, 10 subclusters for each emotion, for example, or long sentences, short sentences. So we have two-level hierarchy in our network. And now we want to update our graph with the unknown speakers. So for every new utterance, we calculate embedding, and we compute its similarity with every subclass centroid. If the similarity is larger than some threshold, we add this utterance to this subclass. If not, we generate new centroids with only this utterance. And after that, we recalculate with this formula, the formula above, we recalculate the centroids, and distances between subclasses might change. So we check if we should merge these subclasses. And in this step, it may occur that our new subclass that we created with its own centroid is not mergeable with any class we know, and thus we derive that this is a guest. So basically we can, during the online training, if we can call it so, of our algorithm, we can add new speakers to the graph, and also if we have a lot of utterance of one speaker, if we didn't know about him anything, if he's not from our family, later he will become the part of the family because we know a lot of information about him. So the algorithm doesn't really distinct some better classes or worse clusters, just it has knowledge of utterances and the distance between speakers. So we got these results. The baseline is just generate graph and choose the closest speaker. And this is like our baseline. It's not good, it's not bad, but so this enrichment is every time we don't just calculate the metrics, we also update the enrollment of every speaker. If we find that it's his utterance, we update its enrollment with this new sample. And our algorithm outperformed these two baselines, we can call it so. So yeah, I think this is all I wanted to say.
Great. So guys, you have a extremely ambitious and interesting project, but your repository really requires some more detailed description, because if I don't have any data sets and in terms of our course, I cannot reproduce your results, or I told you that I need to spend half of the day understanding what should I run and how. Yeah, and that was the main thing why I got upset.
Yeah, I understand it.
So the second point here is that it looks like there is a very nice math in behind, but so if we're talking about some kind of machine learning research, I would like to see a list of hyperparameters that was optimized and iterated through the research and said that, okay, it works better. If we're talking in terms of social network analysis and description, I would like to see at least this synthetic graph and I don't know, some centrality, some at least some visualizations. Yeah, and I understand that you do not want to waste time on some I don't know, useless things because you're very focused on your speaker recognition method. Yeah, it looks so at least. But so while you're not doing this, you're not fulfilling the formal requirements of the course. And that makes me putting you not the best mark that could be in this case. I don't know how can I, what can I do? But so this is the problem.
Yeah, you got a valid point about hyperparams. We have 2 or even 3 different thresholds. One threshold is for lower level and for sub clusters, and one for clusters, and another one like a general threshold, and they all are hyperparameters. We did not tune them a lot, but I guess we can even improve our results a bit with the hyperparameter tuning. So that's why we don't have lots of results with the different hyperparameters, because we want to compare ourselves with the baseline methods, not to outperform some of our previous iterations of our algorithm. And about visualization, it's like there is not lots to visualize, because in this graph it's all very very basic, like the utterances of one speaker are close to each other. Like the form of clusters is there is nothing to analyze from the visual view of the graph. It's like
what if we are talking about very large communities? So we are not limited with the household, or this is just the key condition of your project?
What do you mean about if we have
probably
so the idea here is that you can inject your embedding your utterance from the device that you're doing inside the large graph, and using graph model predict the better, the best speaker. Yeah, and in this case, you will not be limited with 5 or I don't know 6 family members. Yeah, so it looks like you can benefit from network methods if you increase your family size. For example, if you will need to detect the speaker inside the office. Yeah.
We have this here 1,000 families, so we're not like limited to family number of 5. We have
no, but you're limited by the family size.
Not much. I mean,
how your so what will happen if you will have your family size something like 200?
It will
this algorithm. I can say the algorithm is more or less scalable. So on each step, we just compute some dot products.
But
if we have 6 families or 200 families or 6 members or 200 members. It doesn't really matter, but the 6 members is more realistic use case.
Yeah, and also it's like parallelable at each step, so we can scale it very much all the way up. So every number you want.
Anyway, I highly recommend you to publish your results because they're really interesting. But still, I would ask you to frame your project to the formal aspects of the course better. So that's why I a bit penalize your total grade. Okay.
Okay. Yeah, you got the point.
Okay, so let's move on, and the next is the story about Kinopoisk analysis by Sophia, Alexandra, and Maria. So you're welcome.
Good afternoon.
Yeah, hello everybody. Hello.
Okay, thank you.
Yeah, hello everyone. And today we'd like to present the results of our research on the topic related to Kinopoisk analysis. And let's start with the next slide, please. Yeah. I'd like to start with the goal of our project. It is to analyze the 1,000 must-watch films from list made by Kinopoisk. And in order to achieve this goal, we decided to write a Python code that would help us to gather all necessary data from the service. For this purpose, we use specific Python libraries like Pandas, Beautiful Soap, Matplotlib, and the consequence working with this data. Moreover, we used other libraries and model like time, random, and user agent to go through Kinopoisk protection system. After that, we created a number of graphs in Gephi that helped us to identify the number of clusters and then analyze them to find the relationships between them. What's more important to mention here is that as part of our studies at the Faculty of World Economy and International Affairs, we worked on clustering this category of Kinopoisk films in the IBM CPSS statistics program. Therefore, it's also in our scientific interest to compare the results of the previous analysis with the outcomes gained when using new technologies such as Python and Gephi. Next, I'd like to talk about literature. Yes, it will be a brief review of works we resorted to while conducting our research. And there is a large number actually of works dealing with predicting a movie success rate. Among them, we can name those which are written by Bristi, Zaman, and Sultana, where the authors consider various factors that may affect how audience perceive a movie. For example, there is a name of movies, director, its screenwriters, the main actors, the country of origin, genre, IMDb rating. And therefore, it was revealed as a result in the result of this research that some features have more influence on the movie's success, while others features have less or no influence at all. The next works were written by Gross and Glory, and in their work, the researchers tried to predict the success of new movies. For that purpose, they use data collected from IMDb, such as rating and comments, then Rotten Tomatoes, and box office mojo. As a result, it was found that the chance of a movie of getting nominated for an Academy Award was strongly connected with IMDb community discussion level. If the discussion level is higher, then movie has more chances to become an Oscar nominee. By the way, it needs to be mentioned here that the main important feature of IMDb for this kind of analysis is that this service presents the audience perception of the movie in general. But this service also has one remarkable problem, actually. Users can give their ratings to the film biased as the voting is open. That's why more reasonable results of the research, it's necessary to use different metrics in addition to these metrics. The final work was written by Chang, and in his research, he tried to create an IMDb rating prediction model. For this purpose, he used a Sna method and studied a cooperative relationship between the director and the lead actor, the community relationship between directors and actors, relationship between film workers' participation in social network activities. And also, the next slide, please. Finally, I'd like to mention that it's very interesting to consider the experience of Netflix here. When Netflix collects a lot of data from users such as film time of watching, rating film, comments, and number of searches, and this criteria helps the service to create the profile of this user. And this information is used to create a new project. For example, Netflix show House of Cards was created based on audience preferences analysis and gained a great success in the USA and Europe. That's all for my part, and I pass the word to Alexander.
Thank you, Maria. So I want to say a couple of words about our data. As Maria already mentioned, we collected data from a Russian service, Kinopoisk, which has lots of information about films, old films, new premieres, and so on. And for research, we have chosen Kinopoisk list of 1,000 cult movies of all time. You can see the data set here. And we tried to understand which factors are the most important for defining the cult status of the film. And we mentioned that in this list, rating, some films have not very high rating. Some of them have no rating at all. And some of them, of course, have very, very high rating. And that's why we have chosen for our analysis 3 variables, which are directors, actors, and genre. And we create a graph which presents actors and directors as nodes. Edges are links between them. Saying links means that they participated in the same project. And also we used genre as a group variable to divide our graph into groups by genre. But as you can see from the slide, it's really hard to say something about links between actors and directors based on their main genre. But also, it's clearly visible that films of different genres are presented in the list. For the research purpose, it's necessary to identify genre distribution, and we do it with Gephi too, and you can see it from the table on the slide. And as you can see, the most popular genre among cult films from Kinopoisk is drama. Also, we built graphs for different genres. And as you can see from the slide, the biggest number of edges between directors and actors can be seen for dramas, of course. It depends, firstly, on the general distribution of the list of cult films, which you have seen from the previous slide. And also, it allows us to say that cult actors and directors are working mostly on dramas, and moreover, films of this genre can find the higher level of the audience approval. Among the most popular directors who made films in this genre are Marlon Brando, David Lean, Robert Altman, Francis Ford Coppola, and so on. Speaking of actors, Al Pacino and Marlon Brando should be mentioned here. The next step for our research is to identify the most powerful clusters in the network. For that purpose, we use centralities and modularity analysis. Results of the centrality analysis you can see here on the slide. Talking about modularity, you can see that we can see our results on this slide. And we divided the data into 397 different clusters. So this is very too many. And in our opinion, based on the previous centrality analysis, we can define 15 most important clusters, which consist of nodes that have the greatest number of edges. Thus, we can see such clusters here on the slide. For example, we can say a bit more about these clusters. So the biggest one is Orange cluster. This cluster is presented by Altman, I'm sorry, not Altman, Kubrick, McDowell, Connery. And this graph includes the teams of directors and actors producing films in the USA in the period from 1960s to 1980s. Also, you can see here blue cluster. Blue cluster is presented with Lynn, Lancaster, Taylor, and this cluster is for people who are working on films in the 1950s. And also it's pretty interesting that this cluster this cluster is for French movies, and it's strongly connected with American clusters. And about this, Sophia will tell you a bit more. And this is all for my part. Sophia, it's your turn.
Thus, generalizing trends that unite all of the above clusters can be attributed to the divisions of the graph into clusters according to the country time principle. The main content makers in the list of cult films are the directors of the mid-20th century. We can also see separate clusters with directors and actors from the 2000s. So we can also see several actors capturing several eras of cinema development, which causes such a cluster division. The resulting graph shows that the largest number of films which were produced in the United States, which is why interconnected clusters are formed for different periods. It's important to identify the relationship between American and European cinema, which can also be traced in clusters. The spread of American cinema in Europe, and in particular in France and the United Kingdom, not only brought huge profits to American film studios, but also significantly influenced the consciousness of Europeans, created a positive opinion about the United States, about American society and culture. The next slide, please. As the business market of film industries are becoming huge day by day, competition here is also growing complex. Accordingly, these determines the importance of conducting a clustering analysis of the most popular films of all time among KinoPoisk users. So the main cult films, according to KinoPoisk users, were created in the period from 1916s to 1918s. Since we can observe a closely interconnected sectors within the graph. Different directions of cinema influence each other, and thus a single cultural space of cinema is formed. Besides, as a result of our analysis, we identified that the greatest numbers of cult films were made in the USA and Western Europe. Moreover, we found the strong connection between American and French cinematography, which is interesting for the future research in terms of liberal art field. Thus, having selected the most popular films by the film search rating and carried out or CNA methods using graphs, we can conclude that the most prominent directors are Hitchcock, Kubrick, and Lin. As for the actors, here one can name Lancaster and Baccarat. Drama is the most popular genre among the most people directors who made films in this genre are Brando, Altamont, Coppola, and Bonnell. Speaking of actors, Al Pacino, Brando, Lancaster should be mentioned here. That's why it's important to mention that for future success of the film industry products, it would be useful to study the main features of films which were made by mentioning directors. Probably it would be helpful to identify the main features of their works and to impose them into new product. Of course, we are not talking about plagiarism, but as the area of art film industry can use the experience of the past, which can help to develop future product in terms of their quality and artistic content. Film which will be made using results of research probably would be more successful and profitable, not only in a short term, but in a long term as well.
So that's all. Thank you for your attention. We will go to hear your questions.
No, the time is over. But I guess we had a pretty long discussion during the consulting hours, so we can skip it.
Yeah.
Okay, so mood of the nation has been spoken already, and I guess we will talk about student education strategies by Angelika and Ekaterina. Yeah.
Okay. Bye. Okay, so good day, everyone. Evening, probably already. So we are going to present our project. It concerns the student behavior patterns within the public online learning. So the key idea refers to how online learning is influencing the behavior of students and what are the patterns of students of behavior is shaped by online education, while the also switching roles of teachers and students. So we used Sna as a core method in defining these general behavioral structures of student network. And the research goal of our was to identify these patterns of students that are solving mathematical problems with the help of Junior Academy, and to trace the importance of teachers' role. The next slide, please. So we lay down several theoretical expectations that are concerned with our research, and we try to see whether they proved or not proved. So firstly, we suggested that the number of problems and difficulty perception depends on the learning level of the student. Then we suggest that the higher usage of numerous hints leads to lower number of problems. The third point is that being socially active, meaning that the student entering new classes, creating new classes, being a teacher produces more educational achievements, points, and that the more teachers, if the student has more teachers, it leads to better understanding due to the lowering the number of encountered problems and difficulties.
Okay.
The next,
Okay, we have enough big data sets. We have 3 data sets of users, of content tasks, and of problems. We have more than 16 million of observation of problems, and we have done the random sampling of 50 students. It's a very small part, but it was about 10,000 their behavioral patterns, their problems that they have encountered, and they have done 650 type of tasks on our online school platform. And we try to do three graph of problem, graph of students, and graph of tasks. But we have refused from the graph of problems because it was very strange. And the variables that we include in graph of tasks, it was how many times the answer is considered correct from the first time, the number of problems, difficulty perception of level of the task, learning stage, and number of used hints. And the graph of students has such variables as user grade, points received, number of badges, number of classes to which students belongs, number of teachers the students has, number of students that students has as a teacher when they change their roles, and the number of tasks answered by students. And graph of students has 50 nodes and about 600 repeated ages, but without repeating, it was only 150 ages. And before we see our graph, we also find such values that characterized the student performance. For example, the mean of problems that students have encountered. For example, the mean of number of attempts they have done, and for example, the how many seconds they need to cope with the problem. And we have some pivot tables, and we found that such variables as presence of teacher or belongingness to class, they doesn't influence the student performance. They only influence the activity of students on the platform. So the students who are active or who are social active on the platforms, they also active on the platform at all for how many tasks they done or how many problems they cope with. But we also want to say that such variables that describe the changing the role of student-teacher when the students became teachers inside the platform, they are very rare when the students can take this role for yourself.
Yeah, so I will continue with our some statistical indicators that refer to both graph of students and tasks. So we'll start with degree distribution. So for our graph of students, the average degree equals 5.96 degrees, and approximately these are the 6 connections that a node generally has to other nodes. And the highest degree, as can be seen from the degree distribution, is 18. Also, as for the graph density, it equals 0.122, which means that the graph is far from being dense. It is closer to 0 than to 1. Then continue with the next slide, please. Continuing with modularity. So on the graph, on this slide, you can see the graph with our clusters that were created by Gephi. So our coefficient of modularity equals 0.403, which means that the strength of connection is somewhat lower than medium, I would say. So it's somewhere in between, but it's still a bit lower than in between. And you can see that there are overall 7 clusters, but the strongest that are the purple, the green, and the blue one with 26% each. And there's also one more cluster that comprises 16% of the students, this population taken. The next slide, please. So here you can see the distribution of between centrality and closeness centrality. And also we can observe that the network diameter of graph of students is estimated well at value 6, but radius equals 0, while the average path length of the node equals approximately 2.65. And the average clustering coefficient. So in our case, the closeness of neighboring nodes is a bit smaller than compared to the graph of task, as we will see, but still it can be considered significant since it equals 0.611. It allows to assume as a bit that there are some kind of medium ties between the nodes in the graph, and you can see the clustering coefficient distribution on the slide. Yeah, so as for the graph of tasks, as you can see, we generally have 656 nodes and 26,317 ages by students. And so the degree is bigger because the sampling, as you can see, is far bigger than in case with students. So overall, there were a lot of kind of approximately 126 values within the range of degrees. So you can see that there are some more visible groups, such as a degree of 96, which is 5%, degree of 37, which is almost 4%, and a few other degrees that are repeating throughout the graph. According to the degree distribution report, the average degree of our network equals almost 92 degrees. As for modularity, you can see that it divided the graph into 6 core clusters without any small one, and the value of modularity is estimated at 0.5 generally. So it has relative medium strengths of community structures, and we have the strongest clusters, the purple one with more than 20%, the green one with 20%, and I will not count them, but it was really, it was interesting that by the size, it does not mean that the big cluster is inside, doesn't mean that it will be big in person, as in case with like this green in the bottom, which seems to be small, but in reality is quite big. And the next slide, we will see the as well distribution of centralities, the between centrality and closeness centrality. And the network diameter equals 4 in the case of the graph of task. And the radius and average path account for 3 and 2.223 accordingly. As for the graph density, is not really dense, as well as was the graph of students. It equals 0.173, and I will finish with the next slide with the average clustering coefficient of the graph of tasks. So you can observe here the distribution, and the coefficient equals 0.793, which means that it's relatively stronger than it was in case with graph of students. And we can suppose that the ties between the nodes are relatively strong, and they are close enough to be a complete graph.
Okay, we have used the node to vacant clustering, and we in our algorithm, in our code, the hyperparameter p equal 1.5, and the hyperparameter q equal to, because when we use these values, the validation p-score and the test ROC score, they best compare with the other values. And we have used chemist and agglomerative clustering for 2 clusters, and this clustering of our prediction model is similar to the our real graph when we use the variable learning stage to form clusters. And when we use deep Sklein clustering, we have 4 clusters, and it's similar to our graph when we use difficulty perception as a variable for clustering it. And also we use graph of problems for clustering prediction by some variables. We have done for groups of students based on the distribution of their grades. Their user grades shows out the student performance of the platform. It varies from 1 to 11. For our random sampling, it is equal from 2 to 10. And we have done for groups. For example, the first level include grades between 2 and 4. And after this, we take all our variables in our dataset, and we have done the cluster. We try to find the clusters of our random model, and we have found that there are only 4 variables have allowed to us to form the clusters, is similar to our group to our real distribution of these 4 levels by grade. And it's Bayes' difficulty perception of students, and presence of teacher and city of our students. And we can see that the variables described their social activity on the platform, they doesn't allow us to form their model and predict our grade of students. And that's all.
Yes. So I will finish with our general findings that came from analyzing 2 graph of tasks and graph of students. So firstly, we found out at accordance with our expectation, we found out that majority of our expectations do not fit into reality. The first, that the learning stage does not necessarily define the number of problems found and the difficulty of the tasks. So they were as well the more higher students of more higher level that encountered the same amount of problems and found something difficult, as well as the lowest level of like learning stage of the student. Also, the active usage of hints doesn't really lead to the decrease in number of problems. We found out that even in the case when quite many hints were used, it did not lead to decrease. In some cases, it even led to increase in the problems that the students found. There is also no clear connection found between social activity, and particularly teacher's role by student and student achievements. So we saw that there is no connection since the teacher is not really influencing the students' achievements at all. And we suggested that the teacher may influence better, the number of teachers may influence better understanding, but in reality, it doesn't lead to better understanding. It does not decrease problems in difficulty level. And for future, it will be useful to predict which tasks the student can or cannot cope with. And we would like to supplement the student model with adding the characteristics associated with social activity on platform, its changing role, the teacher student, and we will see how it affects the student achievements in more details and a greater sample, because as it seems, the sample of students doesn't allow for bigger and more stable conclusions. That's all. Thank you for your attention. We're ready for questions.
No questions. Over timing for 3 minutes. Do you see any signs that I'm showing during your presentation? Because I'm highlighting you how many minutes are left. So, okay, just to be quick.
No, sorry.
Yeah. Okay, next time I will just shout it loudly because no one is looking at all these tables, 0 minutes and so on. Okay, so quick opinion here is that this is very good work in terms of the visualization, but your computation part is a bit weak, and lots of things can be done to make this work stronger in terms of machine learning and classical optimization algorithms. Yeah, so the idea in just near you is exactly what I told you at the first meeting. You can think of your students as random walkers that are passing through your graph of tasks. And for each student, you can make a prediction if he will succeed in the next task, if he has already passed those, and those. Yeah, and generally, so this should be a very, very interesting model. But I understood that you have no time and maybe skills to build it. Anyway, so we need to continue with the next block, and the next presentation is about the romance of three kingdoms. So I would ask you to skip the block about the description of the novel and focus on your achievements after the second checkpoint, if it is possible.
Yes, we have already did that. So okay. we introduced novel and its author in the last presentation. So in this presentation, we will not introduce the book itself to save time. Our presentation is divided into 3 parts: key ideas of the project, methodology, and results. The key idea of this project is to simplify. Next slide, yes. The key idea of this project is to simplify the analysis of complex relationships in the novel with the help of computing and make literature research more objective and convincing with quantitative methods. And the goal of this project is to generate the social network of characters in the novel via the NLP technology, review the text style of the novel via social network analysis, and compare historical novel and historical facts using quantitative methods, which is we are especially interested in the last point. So next, I will give the floor to Zhou Zhengman. 你麦是不是没开啊？ 龙曼，你麦没开。
And now can you hear me?
Yeah.
Okay. Okay. Now let's move on to the research data set. Our original data are the English translation of Romance of the Three Kingdoms and we scraped the whole text from the internet. And when preparing the dataset, we tokenized the text, recognize the named entities, and finally extract the social networks. And talking about the network design and framing, in our project, persons are considered as nodes, and the edges are co-occurrences of two characters in the same paragraph. And the weights of each edge are determined by the frequency of co-occurrence. And by following the steps described above, we construct the social network and analyze the general information of the network, compare it with empirical networks, and also analyze the main characters by node centralities. And here are our results and analysis. Well, first of all, let's go through the general information of our network. Here, as we can see, this is a huge network with more than 1,000 nodes and more than 8,000 edges. At the same time, the network density is only 0.009, which means that the network is very sparse. In fact, that's unusual for a network from a novel. A novel typically focuses on a few main characters, so the network should be small and dense. However, Romance of the Three Kingdoms is a novel based on a certain historical fact. So this book includes many redundant historical events which are not strongly connected to the main story, which makes the network so big and sparse. And then we compare our network with the networks of real world. An empirical network model typically has three features: Power degree distribution, small average distance, and large clustering coefficient. And the histograms on the left show that the network of Romance of the Three Kingdoms has a Power degree distribution. And here the picture on the left tells us the distance distribution, and the average distance lies between 3 and 4. And so this network meets the feature of small average distance. However, the global clustering coefficient is really small, only 0.250. It's obvious that the network does not meet the feature of large clustering coefficient. This fact once again confirms the conclusion discussed above. That is, as a historical novel, The Romance of the Three Kingdoms includes many redundant characters who may have no attribution to the main story, and these unnecessary characters are not strongly connected and clustered. Yeah, and then I give my floor to Duan.
So the next 5 slides are the top 20 rules we get under different node centralities. The top 3 on the list are Liu Bei, Cao Cao, and Zhuge Liang. To a certain extent, it can be shown that the author has carried out a certain degree of processing and modification in the narrative, because in history, the state of Shu was weaker than state of Wu in terms of military and political strength. The emperor of the Shu was Liu Bei, and the emperor of the Wu is Sun Quan. So we found 2 possible reasons for this phenomena. First, the author focused on the history of the so-called struggle for legitimacy between Liu Bei and Zhuge Liang of Shu and Cao Cao of Wei. Such purpose led him to not perpetrate Sun Quan and the people around him too much. Second, the author has artistically processed the historical facts, changing the original facts of other stories to Liu Bei and Zhuge Liang. adding stories or folk rumors that did not exist in the original history in the novel. Let us make the conjecture based on the historical period in which the author of the novel, Luo Guanzhong, lived, the end of the Yuan dynasty and the beginning of the Ming dynasty, was the time when the country was in turmoil during the war, and the people yearned and the people wanted for a stable regime and the defense against foreign enemies. Therefore, the society at that time generally liked the state of Shu, which had claimed to the succession of the Han dynasty. Another fact we discovered later also strengthened our guess. Liu Bei and Zhuge Liang have the highest rating in the ranking by engine vector centrality. Especially Liu Bei's data is much higher than others. This shows that the author not only focused on describing the story of Shu, but also Liu Bei and Zhuge Liang, two important figures in Shu, because the two most important, and they become the two most important characters in the novel. And for your comments, Professor, we also prepared some answers for you. So the first and second question, how do graphs change from chapter to chapter? And can we in future make a movie visualizing this change step by step? So this is certainly achievable, but we need more time to do so. And in fact, our goal of doing this project is not just to observe the characters of the novel. What we are more interested is to connect it with a real history and see what changes it has been made to the history. In this book, it is very difficult to verify by chapter because the book, the novel itself, is in a time order. So from the beginning to the end of this history. But our history book for comparison is a biological book, which is divided into chapters according to the life of the characters, which could put quite a bit of work for us to comparing the details of the history. Next two questions is for Zhou Zhengman.
Okay, for the third question, can we model the story with the temporal network model? Actually, our network belongs to the preferential attachment model because it has the power degree distribution, small average distance, but small clustering coefficient. But unfortunately, we cannot find some advanced models for this story because there are really a few researches on it. And for the final question, many researches like on Alice in Wonderland and Some Plays by Shakespeare came to the conclusion that a social network of a novel should be small, dense, and with large clustering coefficients because it focuses on only a few characters. And these characters should have strong interconnection. But the network of this book, Romance of the Three Kingdoms, is large, sparse, and with small clustering coefficients. And that's because as a historical novel, it includes many real but redundant characters, and which may have no contribution to the whole history. And that's our answers. And do you have any additional questions?
I guess no. So generally, it's really hard to give some feedback to the area where you do not feel the ground truth behind the research. So since I haven't took this book into my hands, so these are just general ideas. What can be usually done with novel analysis, yeah. I've told you that at HEC, there at the School of Linguistics, that there are several fellows that are making research of the Russian literature. That's why it's really interesting to compare at least your approach with things that they are doing with texts of Tolstoy and whom else they have picked? Pushkin, Boris Godunov, they have analyzed Pushkin also. So you can borrow some ideas from them in terms of the visualization, in terms of the methodology. But these are just the same ideas that I have already told you at the second control point. Anyway, so once again, thank you for your research and for your presentation. Okay, so analysis of the Laplacians from the neuron connectivity structure by Mikhail Tuzhilin is the next report.
Hello, do you hear me? Yeah.
Yeah, great.
Okay. So today I not want to again say about the whole ideas of this project because too many slides are here. I think, but very quick, I remind you the key ideas. So I take the data from this site and collect two tables. First table edges, directed connection between neurons. So I analyzed biological neuronal network that is fully described. This is the network of C. elegans. It's the worm. And second table, I took second table is the types of nodes. So the description of all neurons and their position in body. So there was three parts: head, middle, and tail. And by this, I do my analysis. And at this table, I throw the NMJ, neuromuscular junction, just to say about it. And my network consists of about 300 nodes, 6,000 edges, and here you can see it by colors. So purple nodes, it's head nodes, head neurons, blue ones, middle, and yellow tail. And I remind you the 3 steps or the strategy, so-called TCI. First is try to find centralities and try to classify neurons by them. Second, check to obtain the same eigenvector embeddings, like in the article that I said at previous presentation. And third is improve to apply better method for classification gut. So step by step. First, I calculated centrality distribution for directed and undirected graph. You can see it here, but there was no difference between them. I don't know why. So it's strange for me, but network X works like it on this graph. I don't know. And do statistical analysis of these centralities. You can see it here. There is, yeah. So this is just something like random collection of these nodes. I grouped by these colors, and on this X it is degree, and this is coordinate is just to represent one point for one coordinate, nothing else. Yeah, and this is statistical analysis. So here is just two statistical significant groups. The difference between head neurons and middle neurons by the degree centrality, they are significant, and now results not significant. And also you see about the analysis about closeness centrality. Here was no statistical significant results. Between the centralities also you can see the statistical significance between head and middle neurons and nothing else. And here also by eigenvector strategies, no significant differences. Yeah, so a few significant differences, it's not enough, and it's not show something interesting for me. I don't know, maybe we can also divide it by two groups, the head and another group, middle and tail, and do with statistical analysis, but here is no significant differences. Yeah, also I do here Bonferroni correction because of to solve the multiple comparison problem. Second, obtain the same eigenvector embeddings. So first I use Google it and find eigenfunction and do it by eigenfunction by NumPy Linalch, and this is the result by article, and which is my result. I do all steps at this article. We first delete self loops on this graph, and then calculate. In article they said that we calculate spectral Laplacian matrix, but in another site they said that it is not in Laplacian but normalized Laplacian. So I calculate in this and this, and you see they are not coincide. Yeah, and then so yes, and this function also obtain different minimal eigenvectors if we just swapped coordinates in our invariant space. So if we just swapped coordinates, the minimal eigenvectors should be the same, but the results very changing by just swapped coordinates. So, but eigenvectors are good. Yeah, eigenvalues are good, but eigenvectors bad for this function. And then I Google another function x from scipy sparsely null and do analysis by this function and see here the results. Yeah, so here was Laplacian matrix, and here is normalized Laplacian matrix, and here is a color map for you. And yeah, it is coincide. So it's good result. But so this result is said that we can how to say it in English, we can divide the head neurons and middle neurons by for example eigenvector second, yeah, or so yeah, here is something like clusters, you can see it. And also spectral embedding of Laplacian matrix do something like this. So it's also divide with colors, with groups by an eigenvector second. So sorry, I just miss this. We should not be normalized. It's just Laplacian eigenvector for Laplacian matrix. Yeah. So yeah, I reply with results. It's good. Yeah. And but in the third part, I try to do something with God, but I trying to solve this problem with stellar graph, but no, I have not enough time to solve this. Yeah, some problem with yeah, incompatible packages, but there is no incompatible packages in the description of this error, so I don't know how to solve it, but it will be in future, I think. Yeah, so I'm not fix it, and it will be continued. That's all.
Oh, okay, thank you. So I don't have any comments in spite of some maybe highlights that during this research, Mikhail has contacted with the guys that originally made this paper, and they have sent him the MATLAB code. Yeah, and it was a real story where we tried to understand what's happening. And I'm still a bit confused with this different implementation of the same algorithm in different sub packages, which is very, very, very strange.
Yeah, but I also use, for example, not eigen, but eigen h, because the matrix Laplacian matrix is symmetrical, but also very bad results in embedding. I don't know why.
Yeah.
So NumPy lineage for eigenvectors for me is very
it's
bad.
Useless. Yeah.
Yeah.
And another thing that can be seen from exactly this slide is that the color encoding is a bit different, because it looks like they have a mixture of red and black dots.
Yeah, surely. I just I want to have to do embeddings, the same embeddings, but we compared with neurons by by functions of neurons. At first step this color map is just the position of neurons. So because of that, the colors are different. But for example, it is interesting that all motor neurons, I think, almost all motor neurons are in the middle parts of the body, but maybe it's
generally. So if they have such a good result after the Laplacian function computation, it looks like we can try some other embedding methods, for instance, the GemSec, and see how it will work with this data, because maybe it will lead to more kind of suitable embeddings. And of course, we should still finish with the neural network model and see if it will make the better representation. So, but yeah, the part about improve is still in progress, which is partially ruined by the fact that the library inside Network X and SciPy is working in the way it is not supposed to be. But so this is a real surprise, and I'm very impressed with the fact that you solved this problem finally and found out how to work around it. So
yeah, I also very impressed. I do it today, so I'm very happy of these results. We are coincide. Yes.
So still, guys from the Swiss universities do not lie to us. In fact, they lie to us a little, because they have not told anything about the normalization, but generally the visualization is really the same. Okay, so thank you once again, and I hope you will continue this project and still make the improvement.
Yeah, surely.
Okay, and the next talk is about the media community migration. So Vladimir, Stanislav, Nikita, you're welcome.
We are here. Hello, everyone. Second, I will show my screen. So should I start?
Yeah, sure.
So if we mentioned earlier, our theme is filter bubble effect in time of Russian operation, connection between opposition political groups and UK. As we thought earlier, we tried to show connections, find out connections between different news groups in UK, such as Взгляд, Doha, and now we took a third news page, which is Moskovsky Komsomolets, to increase our data set and to find out more connections and to find out what words and what how filter bubble effect works in such cases, in such groups. And now we have a increased network that Nikita will explain.
Yeah, I will explain the graphics of our network. First of all, we took three media. It's Взгляд, it's Moscow Komsomolets, and Doha. The idea of this media was very simple, that Doha is the media that was forbidden in Russia. It was forbidden in social media sphere in case of their position about the special operation in Ukraine. That was the idea that this media was on the left side of the line, where I'll explain that the line is the left people who are who are against the special operation. On the right one is that ones who are for the special operation, and we want to find the middle media, which is not specifically talking about the special operation at all, but if it explain or showing us news from the Ukraine, they try to make us some kind of neutral position. Well, the first hypothesis of our work was that in Russia there are some media that try to make a centristic position, and also they have only right position, which is not forbidden in UK and in Russia. Well, the second one, no, you can stay in the first graph. The second hypothesis was about that there are some group of people who are have a centristic attitude to the whole political and economical and social situation in Russia and in the world. They are subscribed on left media and on the right media, and for that reason, according to filter bubble, they can cope with this effect and take more critical information about the situation. Due to our research, we find, as I said before, 3 media, and try to make a graph which visualize us such kind of information that the people who are who read news do really connect it on the two sides, two camps, like left or opposition with the opposition position, and with the political position of the Russia. But when we visualize or we make a visualization of these social networks, we explain. We found that there are more people who subscribe on Vzгляд, also subscribed on Moscow Komsomolets, whereas the position of the Doha is very far from the others, and there are only a few group of people who are reading news from these 3 social media. We try to find the question. We may remark a question: why there are so much people from the Moscow Komsomolets and from Vzгляд are connected to each other, and they have a stronger connection than between Moscow Komsomolets and Doha. And you can take to the next slides till the word cloud. Yeah. And here we can make a word cloud to see which information the media show to people most in the 3 different social networks. As we can see in these 3 word clouds, we can see that the Doha is much different from these 2 social media, while the Moscow Komsomolets are closer to Vzгляд by the word cloud. It can be explained by that in word cloud of Doha we can see that it is the war, it is anti-war, it's Ukraine, it's against, and other words which we can by which we can say that it is such kind of oppositional social media. Oh, no, not social, it's media. While in the Moscow Komsomolets and in Vzгляд, we can see the same situation, whereas they are mentioned always the USA. They always they don't mention at all the war. It is a very specific word which is forbidden in Russian media for now. It's a special operation. Also, we can see only news from the Ministry of Defense, from different military structures. For that reason, we can see that it has more which are more close to each other rather than the Doha. And for that reason, you can up to the slide, up to the 10th slide, we have, as it was pictured before, that we have 3 groups which are closely connected. Two of them which are closely connected. They are, as we believed in our hypothesis, that they are in the filter bubble, where there are only keywords like the war, like military ministries, and other ideas that the USA has at fault to invade in the Ukraine. While in Doha, we have the opposite situation, where we can see that it is anti-war position. They are against the war. They always said that it is a war, and so on and so forth. And for this reason, we can see this situation, which you can see in the graph. But as we want to prove our hypothesis that there are a group of people who are try to avoid the filter bubble, we also have a small group of people who are in the middle, connected with Moscow Komsomolets in Doha and the Vzгляд. And also we can see a strange situation that some group of people are subscribed in only on the two media, like Moscow Komsomolets in Doha and Moscow Komsomolets and Moscow Komsomolets in Doha and Vzгляд and Doha. Well, I guess that this it.
Okay, thank you for your presentation. So I'm glad that you added at least one more resource to make your research not so expert interpreted. In fact, my main question is why have you added only one resource? Yeah, because so it looks like you can have two more, four, three, and it doesn't cost you much to scrape this data and make more kind of complex research on the news media. The second question is what social methods of the social network analysis were applied during your research?
Well, on the first question is we will answer that. To be honest, we have a problem with modulating the graph because in the Gephi, while I'm creating the graph of three media, and then when I add the one more, it was the new paper to balance the situation, that it is not only Doha, which is a position part. I saw that my Gephi couldn't modulate the graph at all. So it was like the black circle as in the start of using the nodes and ages. So
since you do not have any additional information about subscribers of the news media, do you need to visualize them? You can just show three medias and the amount of the subscribers in common just with the edge weight, and your graph will contain only three nodes. It is not difficult even for a small PC.
We also faced the problem with the scraping data from Wiki because a lot of news, like regardless news pages now restrict their information about their subscribers restricted, so the parsers do not work well, and let us to take information about subscribers.
And also, while we trying to research the information about the filter bubble, we don't actually need, as we think, the more information rather than the connectivity between the media and the subscribers, because if we find out for example, their interests, we don't find the key idea of our research. We want to find the connections that people, when the people read such kind of news, they will get the same news as well. But and when we see the interests in the open space in the Contacti, in the VK, actually some people don't take the right one. For example, while we parsed the information from the ID of the user, we can see that the person is not liberal, but he is in the Doha, but he is not in the such kind of Vzгляд or Moscow Komsomolets. For that reason, we cannot find more, cannot parse more actual information about users.
Okay, thank you for answering the questions. Anyway, so sorry guys, really, maybe this just demotivated you. I looked like a, I don't know, boomer hater at the control point too, but and this demotivated you for further steps of your research. That's really sad for me, because you can make a very interesting case, because everyone is interested how Russian society is working and thinking about all the news and everything in our real life activities concerning this special operation and so on and so on. So it's a very hot and focused topic. But your current research is still found what we're exactly looking for, and it's hard to believe that this result has been proven some kind of statistically with some advanced machine learnings. And finally, so your entire course project is the list of visualizations, and generally it's just one visualization of these three groups connected with each other. If you had some problems, you could visit consulting hours, and I could help you scrape the data. Several students did it, and give you some more advices on the visualization and the data curation to make this network more clear and more kind of descriptive and useful for interpretation. So anyway, I hope you see the difference between the educational grade and, I don't know, some political asserts. So in your case, I'm still giving this grade because a lot of things that can be done to check your hypothesis and prove your opinion were not done at all. And so, but I'm still happy that you have improved your research after the second control point. Whew. So this is the general feedback. You can make some reply, or we will go to the next speaker.
I think we have no questions. So.
Okay, thank you. So Denis, Maxim, and the analysis of the Russian Duma.
Okay, can you see my screen? Can you hear me?
Yeah, great.
All right. Just a second. Okay, so as we know, we are trying to analyze the Russian Duma's legislators and their possible participation in legislative process. So the State Duma is quite complex state structure, which members are elected and called deputies. And actually, deputies sometimes can create laws. As I mentioned, the State Duma is a complex structure that consists of different formal and non-formal factions, as well as connections. So,
Maxim, I'm very sorry. If it is possible to improve your sound quality, that would be very appreciated, because there are lots of noise in the background.
Just give me 1 minute, okay? Just 30 seconds. 30 seconds. Now it's better?
Yeah, thank you.
Duma consists of 450 deputies from the different parties, such as United Russia, Communist Party, Just Russia, LDPR, and UPP Party. So generally, the major part of Duma represented by United Russia Party. And the Duma structure is as follows. There are 32 committees, different committees that cover different areas of economy, and 5 commissions as well. So what we determine is legislative sponsorship when two legislators, 2 deputies somehow build the connection and finally make a law. And more specifically, we're trying to cover next research questions. The first one is we're interested in the overall degree of legislative sponsorship in the current 8th convocation of the State Duma. Then we ask, is there any correlation between deputies' credibility and co-sponsorship? And finally, what parliamentary coalitions exist and on what basis are they built? Okay, so now let's go to the data scraping. So we use deputies as nodes as we build a network, and the number of laws developed by them in joint connection is actually the edge. Okay. So we scrapped Duma official website, and you can see the results below. So we need the law exactly, and the number of people, number of deputies who worked on this law, and we scrapped the State Duma site for legislators. We interested not only in the names of legislators, but also in committees they work in. This is the table with results. All right, so let's go to the analysis. Yeah, so as you can see from distance matrix we built, so the number displays the number of laws that were created by those legislators together. And what we finally get, so this is like a raw result, the first result of what we get after building our network. Yeah, so the bigger the node, so the much higher the influence degree of particular deputy. And some basic measures of network, such as so. And finally, we have 109 nodes and 492 edges. And so average degree is 9, which means that on average, each deputy has at least 9 connections or 9 legislative co-sponsorship with other deputies. Which is pretty high level, frankly speaking. Even if we comparing these results with, for example, United States Congress. Yeah, so we can see here page rank of deputies, some measures, pretty close to what we got here. Generally, those guys are really experienced legislators. For example, we can see here Oleg Milov from Just Russia Party. He is participant of free communications right now and has a lot of speeches in roughly 1,500. So in general, those guys are basically, for example, most of them are chairmen of some committees or factions, or deputy chairman of factions or committees. Yeah. Just let's look at the clusters. What we have here. So these are committees. This is like a result from GEFI. What we get from GEFI, and we can clearly see different committees like extraction committee, like committee, and some parties as well. And let's look at the Duma factions. So we can clearly hear the groups of people who are connected to each other. So that the basic attribute why those guys connect with each other is basically faction. But sometimes the legislators from other parties can join and make laws. So those attributes were actually formal things why our legislators are made laws together, and there are some not formal underlying connections. Just talk about lobbyism and business connection in the Duma. Actually, I took so it is which are not lobbied by, for example, the first committee lobbied by Ministry of Defense, and the guys from this committee actions with Sergei Shoigu, for example, Mr. Kartopolov, the former deputy of ministers, and for example, Mr. Sablin has business connections with Andrei Vorobyov, who is the son of best friends of Mr. Shoigu. And then we have the Committee of Financial Markets, and we have here the main lobbyists such as Association of Russian Banks, and even international banks such as Credit Suisse. And finally, we have guys from Communist Party. They generally, they in common develop laws in the field of education, in the field of agriculture, and main lobbyists are the first guy is who's the owner of big agriculture company from Rostov Oblast, and the final, the last one, I guess you know who this is. This is the Pavel Dubinin from Sarkos in Lenina. Okay, let's go further. And just some, okay, yeah, this is the results of our models. We ran our network from these models, and some limitations. So we are only focusing on deputies, but there are other legal structures like court, government, and senators from other state structures. And we didn't take a region and others. And some other characteristics of deputies. What else? So list of deputies might change over time due to the death, for example, of, I don't know, Mr. Zhirinovsky, who passed away some time ago. And aid communication is far from being over, so found coalition will change over time. This is it. Thank you for your attention.
Great. I really like the picture with fractions because it's very descriptive. Yeah, it's the few steps early one. The previous page. Yeah, because it makes a lot of ideas about the structure of the fractions, and we can clearly see that guys from the Just Russia are some kind of more closely connected, even though they are one of the smallest party in the entire parliament. Yeah, and this is very interesting, and you can extract lots of ideas from this picture. Yeah, so this is good. And the idea with
I guess I know the answer.
Oh, okay, so
I guess I know the answer why, because this party actually trying to compete with United Russia, I don't know, in the field of lawmaking, I think, and some people, some political specialists are even trying to say that this is like second United Russia now.
Okay, so generally, you know, the further steps if you would like to continue this research. So first of all, maybe you should really talk to Vinogradov and see what is his opinion on your pictures. The second is, although, so it's very nice that you have added extra graph connectivities like Ministry of Defense and economic connections. Most likely there are much more of them. And it would be also interesting to add all these economic connections and see how the network will change. Yeah, because lots of them are absent in your current study. So I really like your current results, and there are lots of things to make them even better. So this is some kind of conclusion.
Sorry for interrupting you, but just a little addition. In general, these companies or industries are like really strong drivers for legislation process in the state.
this is an expert opinion unless we will prove it from data. Yeah, and if you show that these are strong connections and other connections are not important, if you add them and show that they don't form this collaborator system, then I'll agree with you. But right now, this is some kind of cherry picking example that still needs to be proven. And in terms of the formal methodological things, yeah, but you're on the right way. Yeah, that's the idea. Okay, so
I got you.
I guess we can
Thank
move
you.
on. Yeah, thank you very much. And the next speaker is Bobin Daniel with the Glassdoor vacancies text analysis.
Can you hear me? Oh, okay. Just a second. Yeah, so my work is analysis of advertisements of working vacancies. Introduction: the ever-changing IT environment brings just a second brings kind of chaos into job seekers' decision making in planning their further education or employment. General programming and IT trends do not 100% correspond to the real world environment, where the companies need something else other than like your general data science job application. And that brings out the question of what the employers really need from new recruits. So previous research, I've found a few researchers, but I can mainly talk about two of them because others were kind of closed for me because of, I don't remember the name of the site, IEE or something like that, which doesn't allow HSE students to log in without like paying or whatever.
In fact, I have access to the AE library, so you should, if you're still interested in these papers, just to write me a message at Telegram. Sorry for interrupting.
Yeah, okay, I would like to, but I've actually found an open research here, which is kind of what I've been looking for. So the first is knowledge, just a second. Yeah, knowledge extraction from online vacancies for effective job matching. The main idea was they used a lot of data from resumes and a lot of data from vacancy stacks, and they just basically try to find the similarities between them to find out how much, to train the model to how much a person is capable for the vacancy. And another one, which I'm really looking into right now, using ontology for natural science and technologies for vacancies analysis, because the basic tag they used is to use quite a big ontology on a lot of topics such as NIT to find the keywords we want to find in the text, such as requirements, responsibilities, and working environments. So goals of the project is to use an existing source of skills data to parse and understand real world industry needs and try to see if existing user data corresponds to a company's needs. So data collection was made by scraping the Glassdoor site by using around 10 most popular IT jobs right now, such as data science, testing, web development, and so on and so forth. The data we compiled was the position, the city. The cities regarded were London and San Francisco because they're one of the top earning cities, or like they were called one of the best of IT cities. The job title and mainly the job description. Additional data such as company location and size of the company and especially like revenue were also scraped because maybe for further analysis. And also I used the Kaggle competition, Stack Overflow. Well, not like a competition, but a data collection, Stack Overflow Tech Network. Mainly because I've only recently found out that there was such a thing as Stack Overflow users, where developers could post their developer stories and tag the skills they used like in their job, and that will allow them to seek better jobs for themselves. So the first approaches to this were bigrams by pointwise mutual information, given the least common co-occurrences, because the most common co-occurrences, of course, the very common words, and also I try to use BERT to try to find the flag sentences such as what we would like from you, and that would correspond to the list of requirements further down the vacancy text. So right now I try to use the network of skills compiled from Stack Overflow, and the data on Kaggle was quite nice because we can see that degree distribution isn't that high. So that means that we can easily clusterize our skills, such as, yeah, okay, I'll try to enlarge it, such as like, and get clusters such as programming with Python, C++, Java gets its special treatment as usual. Android near Java, and the web development frameworks such as PHP, JavaScript. And what I basically have done is try to use these keywords which were tags on Stack Overflow users, and try to scrape my scrape data for this. The following graph is what I got from it, because what we can see here is that almost everything is interconnected with everything else, because I guess that in a real world environment, we either have to have really lots of skills in like not only programming and development, but also in something like development operations, testing our own programs, because as we can see here, the degree distribution changed quite a bit from the previous slide. Now our biggest degree distribution is 30, and the centrality of our nodes by degree and betweenness, the degree is higher, but in betweenness is lower, because however you look at it, almost everything connected to everything else, and that brings some problems. And also I've tried to see, as you can see, I've tried to analyze the number of nodes and number of links. So in the first slide, we have about, not about, but 490 nodes and 115 links. But in the next slide, we have 79 nodes, which is lower, and 1,321 links, which is about like 4 times bigger than the Stack Overflow data. And also we have less amount of tags used, such as machine learning, iOS, and something I don't know what is used for. Probably because in like real world, I might have not used the best approach to clear my data, and okay, some of those should be in the list, like machine learning and iOS and Amazon Web Services. I guess they were in my data of Glassdoor, but somewhere they didn't get into the list, probably because of my code for clearing the texts of vacancies or whatever. And I tried to find the connected components of the graph, and basically everything is just in one big slump. Yeah, so what I would really like to see is, with this approach, I wouldn't expect the experience with modern software development lifecycle tools, but Git and Jira are okay. And yeah, the results are kind of disappointing because I wanted to at least get a network, find some clusters and visualize it properly. But as a result, I would say that real world needs more than people usually find as their main points, because with things like development, you at least have to be good at like databases, the development cycle, such as Git, and not only with development languages such as C, Python, C++, and Java, which I think is why Stack Overflow stopped the project, because I don't see a very good correlation between the data users themselves put in and what the companies really need on the field. And I guess that's it.
So thank you. You know, I guess you just were your generally right research was ruined by the real world data, and the truth here is that you know, companies want people who code Python for 30 years, and but they should be younger than 30 and fight alligators with their hands and so on, so on. Yeah, and in fact, companies don't know what they are looking for, and that's a bit ironic. But so still, in terms of the social network analysis, this is a pretty nice survey of what is happening in the area of the employment market. Yeah, so thank you for your speech.
Yeah, thanks.
I have published several messages about our exam. So generally, you can see that if you have at least 4 as the cumulative mark, then you don't need to meet me tomorrow at the weekend, and I'll be pretty happy if no one would like to talk to me, because so generally, first of all, yeah, it's the weekend, and secondary, usually people get better grades on their course projects rather than when taking the exam. And yeah, Evgeny has pinned the table with the final grades that you will get after this course project defense. I'm slowly updating your cumulative marks while you're talking, but so just to highlight what's happening. And if you, once again, if you still see some mistakes inside the table, just write me a message and we will find out how to resolve it. Okay, thank you. So let's move on. And the next talk is on
just one
the
question.
climate change. Yeah, okay.
Just a small question. So we will get our final grades after this calculation.
In fact, you already can compute them if you move your current value of the total cell from the course project topics to the CP3 cell of your individual grades. And one more point, as I told you earlier, so generally you can balance your cumulative group mark if you have worked in teams of 2 or 3 students in such way that if your total grade is, for example, 9, then one student will take 8 and another student will take 10, because if you say that this student worked harder, so you can rebalance these grades. So, but you need to write it to me explicitly. Otherwise, I suppose that I will just average. So I will put you all. I will put all participants of the team the same grade for the course project. Yeah.
Okay, thanks.
Okay, great. So, and the next talk is on the climate change survey by Seolis. I guess I'm
yes
correct. Yeah, thank you.
So 1 moment, please. So it's my turn now, and I'm going to tell about the social network analysis of climate change. So this, the main idea of this project is to analyze Twitter data in order to evaluate people's feelings about climate change. About the goal of this project is focus on the relationship between the climate change and the environment by combining social network analysis of climate change with sentiment analysis. So this is how I collected the data. First of all, I collected the data using R on the Twitter developer portal platform through the Twitter API. And the word here, it was the climate. So furthermore, the time period of tweets, it goes from May 27 until May 28, 2022. And the following are the main steps in collecting the data. First of all, I created a developer account on Twitter. Second, I set up our environment and use the shared tweets to collect this data. 1 moment. So this is this is my data. The first column is about user ID. You can see here there are total 120,000 entries around, and there are 90 total columns. So the second column is about this. It is about the status ID. The third column is about the data of each tweet. And the fourth column is about the name of each account, if its Twitter account. So this is when I imported my data to Gephi software. You can see here that the total amount of nodes, it is around 70,000 nodes. And the total amount of edges, it is around 110,000 edges. And the second table, it is the initial part of analysis with my data. So this is graph with colored communities. We can see here in this graph separates the communities in 7 or 8 colors, if I'm not wrong. Here we can see that there are green community, there are blue, purple, gray, orange, etc., etc. So here is how my goal graph looks like with the important names. Here we can see that the pink community here, there are accounts like Mike Kudema, who is a Canadian activist who works with Greenpeace. Here, there are also accounts like Climate Human. He is a NASA climate scientist who is called Peter Kalmus. And maybe here there are only English speakers. So about green community, there are accounts like Fiji PM, who is the Prime Minister of Fiji country, and in this group, in this group, there are people who speak maybe Hindi, Fijian, or English. So the third community is the Greek community, and here there is account like Greta Thunberg, who is a young activist, and in this community, there are accounts how we can protect the environment. There are provide information about how we can save the environment. So here is the centrality measures of my data. I collected data only about the petwiness, the betweenness, and the eigenvector. Here we can see that the first account, the Prof. Straken, is evaluated to several classes on a network. And about the eigenvector, you can see that the same account, the Prof. Straken, has the largest influence rating of 1 in the entire network. So here we can see the 8 highly significant topics. We can see that the first topic, it is about maybe about economic impacts in the by climate change. The second topic, maybe it is about impacts of climate change. And the 8th topic, it is about the oil, gas, and the climate change. So the first graph here, we can see when it is about the graph when I did it with the page rank centrality. And here the first graph is without prevent overlap. And the second graph, it is with prevent overlap as behavior alternative. So here we can see that the most numerous communities by name, it is the account of Greta Thunberg. And in this graph, you can see that the most numerous communities, it is by page rank centrality. And the most numerous community, it is the Greta Thunberg, followed by Mike Hudema. So here we can see the links of Greta Thunberg, and we can see here that the Greta Thunberg interacts with green community, with purple community, with blue, with orange, a little bit with orange, and etc., etc. So, and the last graph is about the most numerous communities by modularity class, and here we can say that each community is connected on its own with geographically or with common languages. So thank you for your attention.
So generally, I have told you the feedback. So there is a very few math behind this research, and this is a bit sad. But generally, this is also a very nice and yeah, QR code is pretty good. Although in real life problems, we have in real life practical tasks, very often you need to make nice description. So who is interested in this area, what those guys are talking about, and how they are connected. And usually there are lots of this kind of researchers at this course, and this time there is only one such made by Cepodis. Sorry. But so it's still very interesting to see it, and it was done in a very detailed and kind of good presenting way. So this is the general feedback. Thank you for doing everything in time. Okay.
Thank you very much.
So hate speech in Russian forums by Ekaterina and Simon.
Yes, hello. Can you hear me?
Oh, you're just dying, seems like.
I'm
You
dying.
are really hate speech.
And I'm dying because I just realized that my function for lemmatization didn't work. And yeah, I don't know where my mind was the whole time, but in my network words are not lemmatized, and I'm only now realizing that. But that's okay. Yeah, so the goal of my project of our project was to explore the pattern of hate speech in Russian forums, and also build a classifier for target group prediction. And I see practical application of it in building cyberbullying recommendation, not recommendation, recognition system. Yeah, and I think that well, it's a very arguable thing if it's needed in the modern world, if it's like a censorship, which it is, so it limits freedom. However, I think with the rise of the school shooters, who are incredibly often so-called internet trolls or incels, I think there is some ground for better moderation of it on anonymous platforms. And there were some personal sub-goals which explain why certain methods were used, which is basically trying something new. And also for me, it was interesting to compare how social network analysis methods compare or perform next to some NLP methods or models that are normally used in NLP for text classification. We changed the data to crew HateB dataset, which was compiled by some students on my program. And it has toxic comments from Dvach and Prodota websites for, well, Prodota is, yeah, mainly for the game, but comments there are not only about the game. And dataset also has some non-toxic comments from some forums, but it was just used for their model prediction and I didn't use it. In this, so all the comments, all the responses to initial comment were toxic. And there were 7 target groups: women, men, LGBTQ, migrants, place of birth, age, and other. For this data, the extraction method was the following. So there were word identifiers for each group, like shlucha for women, and they were detected by searching similar words using Rus Victoris. And also search is, I think, a keyword search, but more morphological one, with some parts like Zadi, Mazi, and so on. And then I also realized, yeah, in my network, when in the paper, that there was this big word "eto," which I think might have spoiled results a bit. So I changed it and got rid of it. And this is how it looks now. And let's take a closer look, but using maybe edge between us and community. So we can see that there is a cluster that contains 3 target group at once, meant to insult a man by insulting their mother while insulting migrants, which, yeah, I think just proves how hard it is to analyze hate speech. And the target group is not all, like the definition of target group isn't clear when we're talking about hateful speech. We see also some connection between 2 target groups, such as gay people and men. So with words like pideras. There are close clusters, which is just a funny observation. There are some clusters about wasting time on higher education, which I think just shows bias in data. That's why I mentioned it, because maybe a lot of it was scraped from some thread about discussing higher school, no, just higher education, such as cluster about discussing some Mongolian suffixes. And we also see a clear distinction between target group migrants and place of birth, though Hahali seem to be more semantically close to gay people on Russian websites than foreigners. And here is just another community metric. And here, well, almost the same, obviously, but here, for example, migrants and place of birth clusters are a bit more connected. And I wouldn't say actually that there is a strong target group or cluster for women, just mostly for mothers. And it's also connected to gay cluster by words describing sex, which sounds more like rape. Here, with the node degrees between us, so degree to which nodes stand between each other, nothing very that interesting, but I think if I understand correctly what it means, that Hahali seems to be connected to target groups like I suggested, and also, for example, pideras and other words are just common Russian swear words for any situation, I guess. Yeah, and then to the disastrous part of the research, where I spent majority of time of project trying to understand graph networks, and there was also a problem with validation data properly, as classes in the data are extremely imbalanced. And I'm not describing the parameters because I just used the default ones here, and I unfortunately didn't have more time to try and maybe tune the model a bit. But while I was listening to other presentations, I quickly trained some two-layer convolutional network, also very basic, and got maximum score of 0.23. So I think it's good news that it's also low, and the class imbalance and ambiguous nature of comments are like, that's what I blame the low results at, not just myself, but also on data a bit. So yeah, the results with these projects, there are some useful insights into hate speech in Russian forums, mostly about how mixed victim groups are and how creative language is, which I thought, because there was, I mean, maybe at some point it did get lemmatized, because there are obviously some words that are not really recognized, but lemmatizer or lemmatizes them incorrectly. So they keep repeating. But now I've realized that, yeah, I forgot, or lemmatization didn't work properly. Yeah, and also poorly performing model. So for future, to make the research better, I would balance our data set and also consider researching provoked, unprovoked toxicity. So get like a degree of toxicity. If it's caused by a toxic comment, that would be one thing, but if it's caused by non-toxic comment, that would be another, and it would mean that it's more toxic, actually. Yes, this is it. Those are the results.
So there are lots of comments. I guess you have seen them, yeah. So generally, I have two main questions. Yeah, the first one is maybe it would be worth continuing these kind of research in terms of analyzing how these toxic speech is being spread through the network structure, because here we see the targets of these some kind of I don't know, hate speech attacks, yeah. But where do we observe those kind of attacks? Yeah, and it would be interesting to see at which topics do we meet those comments more or less often. And it would be interesting to map these to the community structure. The second question, so the first was more like a comment, but so the second is the question. I can see that there's the teammate from the faculty of math, but so what is your contribution and what is contribution of your teammate? Because it sounds like the entire project was done by you.
He helped me with like understanding the degreenness, betweenness, and the metrics to use, and also we wrote. So the by me was done just the coding part, but the literature review and then writing the paper as well, and also explaining some things like metrics to me was done by him.
Okay. Okay, thank you. Then I guess, and thank you for being quick. And I guess we can move on to the next speaker, Dmitry Kuznetsov, Alexandra Mishkina, and Gleb Yeremin on the Board Geek community.
Yeah, we're here.
Great, so you're welcome.
Okay. Could you see my screen?
Yeah.
Great. Okay, just for recap, let's define what was our goal. We are talking about Board Game Geek community is one of the hugest site about and community about board games. Board Game Geek rating of board games, the most popular and the most authorical авторитет. And let's define how it works. There are lots of games presented on the site, and there are users registered on this site. They can set their ratings, express their preferences about particular games via from 1 to 10 ratings. And moreover, there are different board games which contains different forums, for instance, reviews, rules, questions, strategy description, and so on, in which every user can create a thread where he can express his opinion, write some question, or leave a message, and other users can reply to these messages. Okay, we set last time we set it such goals. We want to find misleading posts. We want to find expert reviews. We want to exclude biased reviews from our analysis, and so on. As you advised, in this part, we narrow our vision to just one goal. For corresponding user, we want to provide unbiased point of view from one expert. We want to find such an expert on the forum which likes or dislikes some particular game. We want to extract expert position on this game which is suitable to our considering user. It means that his gaming experience kind of similar to a corresponding user. Okay, let's take a look to our code and to our experience. I want to define how we constructed a graph. We consider different types of graphs and so on. And the final one is this. First of all, we constructed a graph for each game, for each particular game. For instance, this is Eclipse Second Dawn for the Galaxy, and the graph represents how users interact with each other. Every point is some user, and the edge exists only if there are directed edges, and directed edge exists if somebody reply to the author's авторский пост. Чтобы полностью быть прозрачным, я по-русски еще раз проговорю. Типа существует ориентированное ребро, если человек ответил на форум, то есть ребро торчит в сторону автора. Okay, sorry for Russian. And let's go further. We consider different versions of weighting and so on, and we notice that from one game to another, there are non very unique forums titles. There are crowdfunding, general news, organized plays by forum, and so on. And we just can manually weight these forums from our vision, which is more appropriate to expert use. We wanted to give more weight to that forums where experts should express their opinion. For instance, if it is an expert, if somebody is an expert, he must write at least one review or at least one strategy guide or so on. That's why reviews forums have the highest rating, and some general forum or rules questions have the less one. After that, we apply a softmax function and so on. Okay, we constructed the final graph. The final graph for the eclipse, it's look like this. We can see that this one, this one, this one, and this one is kind of expert. They have lots of incoming edges. And let's take a look at some statistics, for instance, centralities. And because we have a directed graph, actually centralities analysis is not appropriate, is not suitable for us, because some guy who has different ages from it, because he asked lots of questions about rules, can have a high level of degree of centralities. That's why for the we tried different statistics, but the final part is page rank, because page rank is more suitable for us. It's more описывает смысл which we want to express when we find expert. It's the
What about eigenvectors?
Eigenvectors is quite similar to the page ranks, but I guess eigenvectors is similar to the centralities, because it's okay. We can discuss it after presentation. Sorry.
Okay.
We picked page rank. After that, after we list our experts, we want to filter. We want to find the most similar to a considered user. We picked up a collaborative filtering model we constructed because it's a recommender systems model, as we constructed a Python client to our XML API. We also constructed collaborative filtering model. I can show it later, and learn it. This is the not simple collaborative filtering model. It's latent factor model, which we learn via alternating least squares and fit it. We get from at final almost one mean absolute error, which is fine because we at least predict degree of value. В порядок попадаем. Okay, let's try to use our application. We constructed CLI interface to our model. Okay, we can run it. We have a help page, which can give us some information. And let's give some word game. For instance, let's consider SERP. Yeah, this one. we can consider SERP, and let's take some guy, for instance, this one. Okay, we run our application, and what we can see, we have brief description of our board game, which we parsed from the site via API. This is brief description, name of the game, logo, if we wanted at some point to construct a Telegram bot, player's number, playtime, and so on. Some simple graph statistics. And next part is the most interesting. It's 3 parts, news parts. We considered, we took the most appropriate expert from the news blog, which, for instance, it's very interesting because what our model extracted Jamie Stegmaier. We can take a look at his thread, and as we know, Jamie Stegmaier is a constructor of this game, of the SERP game. He is a designer, publisher of the SERP game. He has different achievements and so on. He's actually the most expert in the news blog. That's why we consider it in the отдельный part. And let's take a look at reviews. For instance, our model picked iLotto and Unprinted, and they have, for each one have reviews. For instance, this one with lots of replies. And if we take a look at this guy, we have here, he has 250 games, lots of ratings, and so on, so on, and so on. And if we take a look at his review, we actually can find that this is a good review. For instance, we have another guy. He has a quite big review, and moreover, lots of different users. And the last part is quite an interesting part, a strategy block. Some guys experts in the games, they don't write an expert reviews, but they write how they can vary a new game, how you can create some home rules that can give you a bright new experience in the gaming process. For instance, this guy can give you a strategy guide about this game too, and lots of different expert users replied to this post too. If we take a look at the Eclipse game, there are more funny results we can see from our model. Okay, I guess I took a lot of time, and I can finish my presentation. Yeah, I can finish, and we can discuss questions.
So, okay, in fact, so this is really splendid because you have done a lot, and this demonstration of the system is exactly the thing that I missed when I looked through your repository, because as I remember, it was a bit messy, yeah, and I wrote you something about it. But so generally, this is very, very, very cool. And in fact, something similar was done by Christina about the ODS community. Of course, her final goal was to pick the best answer to the question. And it's very, 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 very similar to your case. So generally, he took the hard way to solve this problem using graph attention networks, and had lots of problems just inside. And you took a more simple network model to generate the expert weight, but that looks still very, very efficient and useful. And the final block with the collaboration strategy is just perfect. So the general recommendation is that you can use more advanced and smart methods to pick experts, and you can borrow some ideas from Christina, although they were not very successful, but I believe that there are lots of things that can be improved. But all the rest is just splendid. So are you going to launch some bot or, I don't know, some web page that
because I am a big fan of board games, I was offer of the sim, and probably yes, and we want to finish this model a little bit later in the summer, and probably I guess that we will need a bot for this so this model to our self convenience.
But so it's still very, very, very ambitious, yeah, and very interesting to listen. So thank you very much, and
thank you.
In fact, so I guess this is a very practical result, but still it can get published if you would like to. Yeah. Okay. So thank you very much for giving a talk. And okay, conspiracy theories and Turkish Twitter network.
Yeah, we are here. Probably.
Okay.
Yeah, I see everyone.
Great. So just answering your comment inside the chat, I'm some kind of normalizing your results in my head, taking into account your background and your skills, because you can see that there are lots of high marks.
Yeah, I see.
Yeah. So, but generally, yeah. So it's hard to compare.
Yeah, I mean, like, I don't know if they're computer science students or not, but like installing Ubuntu was itself like extremely hard for me. But I mean, some guys have like practically, like they're just showing off at this time, and I'm really impressed. So, can you see my screen?
Yeah.
Okay, great. So I will start from up here and let's go. Okay. So for this project, we have decided to visualize the impact of the conspiracy theory spreaders in Turkey's Twitter network for the last 30 days while finding common grounds between their arguments and conspiracy theories in general. We have decided to create a corpus-like object which contains most commonly used words within articles of fact-checking organization. And following this, we have applied text mining to retrieve articles. Additionally, we handpicked some of the Twitter users that spread conspiracy theories on a regular basis. After analyzing all their tweets, we have combined two corpus-like objects on one data frame, and we have picked most commonly used words and analyzed their impact over the Twitter network in the aftermath of COVID-19. So we are expecting conspiracy theory networks to be isolated and contain similarities with global conspiracy theories. And we have derived our tweets from Twitter via Twitter API, and we scraped the articles from the websites of Doğrulukpayı and Teyit. Our methodology mainly focuses on data scraping, text mining, social network analysis, and semi-corpus creation. And we have decided to focus specifically conspiracy theories related to the COVID-19. With respect to this, we have text mined widely used websites such as Doğrulukpayı, and their Sağlık section contains various articles that contains claims and truths behind them. Since site is working under Selenium, we have decided to use Python for text mining. After this, we have used our language for text mining and selecting and nesting the tokens. And we have filtered the words with Turkish stop words archive and retrieve with library stop words. And after this, we have started to create our second semi-corpus objects. And like, wait a second. Okay. And we have analyzed the users' tweets, and we got their timelines and selected every word. And these are our first 4 results. And this is these 4 are the 4 main conspiracy theory spreaders in Turkish Twitter network, according to International Fact-Checking Organization. So we have found some similarities with global conspiracy theories, but let's okay. And like when we analyze the frequently used words by the Twitter conspiracy theories, whom we examined in our study, we can deduct certain general ideas and personality traits that are commonly demonstrated by conspiracy theorists. In the literature, there are several personal traits and psychological tendencies, and our findings can be connected to these traits and tendencies in order to demonstrate the effectiveness of conspiracy theories in our case. Usage of the words like devlet, Türkiye, which refers to state and government, and they're not surprisingly in those tweets, users were portraying the government either as a part of a global conspiracy or a victim of such conspiracy, eventually calling for questioning the social roles and purporting the disobedience to the authorities in matters related to the conspiracies, such as in the issues of COVID-19 measures and vaccination. These are, I don't want to spend a lot of time on this, but it is similar to what we expect actually, and we have cited every possible source in this case. And you can find it in our GitHub repository. So I want to move on to finish it in 15 minutes. Well, network, we have used users as nodes and retweets as edges. Most of the time we have used stress layout and focused on the last 30 days. You can see our network, our first network in here, clustered with Luan algorithm. Nonetheless, too, as we will demonstrate it later, you can see the general properties of the network in here. After this, in here, you can see other network properties such as closeness centrality of the nodes and of every node, and degree centrality of the nodes, and between the centrality of the nodes and eigenvector centrality of the nodes. We will talk about this later on in the conclusion part, as you suggested. But let's keep on. So this is our main network. We have selected the biggest fully connected graph, which contains our conspiracy theory spreaders too. And in here, you can see nodes with degree score more than 200 lighted up with light green. And you can see it in here for 150 and similarly for 50. And you can, these are nodes with high bit centrality, which is intuitive when you look at the graph. And in here you can see we personally selected the Twitter users. In here you can see Abdurrahman Dilipak, which is one of the big conspiracy theory spreaders. In here you can see 5G virus news, which from the name you can get that they're spreading conspiracy theories. And after that, we just labeled with users with highest degree centrality score. You can see that in the left part, we found out that conspiracy theory spreaders were all connected to each other. And I will show that a little later on, but in here we can see our first results. The graph indicates that gives clues about conspiracy theory networks, since users on the right are authorities and they spread information similar to the government channel, but users on the left spread misinformation constantly. And we will talk about the similarities between these and the literature in general in a few slides. Well, we have used different clustering approaches in here. So we have used walk track clustering, which found more clusters than Luan algorithm. And in here we use spin glass clustering, which nearly gave the similar results with Luan algorithm. And we can draw some conclusions from our network. So first conclusion is conspiracy theory spreaders are connected to each other. And unlike authorities, this indicates a lot, because authorities are not retweeting from each other, but conspiracy theory spreaders constantly retweeting from each other. And what we have found is that conspiracy theories and those who have spread the conspiracy theories from an isolated group of users who have almost no relationship with those who give reliable knowledge. In here, we talked about homeophily. Our network contains homeophily because, as you can see in here, Okay, in here, the left part, the conspiracy theory spreaders part are heavily like separated from the other side of the group, which indicates that they're kind of creating an echo chamber. And this is pretty common in conspiracy theories because people are generally share similar tweets with they believe that like they're just checking the similar ideas with from similar users. I mean, if one believes in a conspiracy theory, they're probably just following the conspiracy theory spreaders, but not the authorities. And we talked about our other studies who found homeophily networks generally, and they're also suggesting that collective intelligence web tends to lead the creation of echo chambers, which is highly polarized and shaped by information biases. And this similarly, this is not just for conspiracy theory spreaders, but people who believe in authorities too. They create a homeophilic structure, and that can be seen in our graph too. And we have two suggestions. Elimination of the bots is required because, I mean, we didn't eliminate the bots. Probably like we could have used certain time stamps. I mean, for like regular tweets tend to be bots usually, or like accounts created like recently, and corpus size can be increased and it can be linked to a context, because I cannot guarantee that like these are, I mean, I checked all of them with my hand, but I mean, probably with a higher more than 30 days time span, probably we would flip some non-conspiracies to the conspiracy groups too. So these are that, and you can find in our repository in here and some documentations about what we have used in while creating networks. And these are our references. And that's that. And thank you for listening. Yes. So I should open my camera probably. I'm ready for bashing. I cannot hear you. I'm sorry.
Yeah, sorry. So the main question, I have understood that you had some limitations in terms of data scraping, and you have answered the question about 30 days. So that's very clear. Thank you. And I'm very happy that you added some descriptions of your network, although it looks like they should have been done in the logarithmic scale, because you have lots of points at the bottom.
I seen it from your face when you see the graph, you just make this.
Okay, so the general thing that I want to highlight for you is that you have lots of nodes in your network that are connected only to one node, the root one, and this looks a bit biased, because most likely they receive information from other sources and they are interconnected with each other somehow, and it looks like this information has not been scraped, so you haven't took it in your analysis, and this sounds a bit dangerous. So I may be wrong, but most likely there are lots of other connections between the nodes that you took into account, and to make more kind of responsible and trustworthy research, you should take into account the connections between the nodes that you focus on. Yeah, so because most likely your leaf nodes are interconnected with other spreaders with each other, and that changes your network structure. Yeah?
Okay. Yeah, you're right, but probably like we analyzed just last 30 days, but if we could analyze, I mean, Twitter API just limits after some point, like 5K tweets. After that you need to pay. That's like the whole motto of the Twitter API, and I'm not going to pay to Twitter. So
if you just take one more consulting hour, we can discuss how to
Okay,
handle
that
this.
would be great actually for further researches too. But I would like to say, if I would like make probably if we could select the time span as like 1 year or so, probably we could have find more related notes. I mean, but just the 30 days, it works like one tweet, and after it spreads and stops there.
Yeah, but guys that participated in this spreading, most likely they have other news at their feeds and they're spreading someone else, and maybe those someone else's are from your network, and they should also be taken into account, even if they're not spreading the conspiracy theories. Yeah, because your network is just the network of the spread, but the entire network of people is different from the spread network. Yeah,
yes,
the thing that you have visualized is the typical information cascade. Yeah, just from our 6th lecture. In fact, I would be really happy if you added the block about cascades to your research, because it looks like this can be done on your data. Yeah, but generally there are lots of other information flows that those guys participate in, and to prove that they are real spreaders, you need to show this cascade at the entire system of connections. Yeah, and this would be much more trustworthy. So this is the thing that can be improved. But I understand that you have some limitations, and everything was done on R, and our course was done on Python. So you had the problems with this language switch.
Yeah. That was I know that was extremely hard.
Generally, I still recommend you to learn Python, because most of the machine learning things and social network modeling is still done in Python. Yeah, you can work with iGraph, but generally Python gives you much more possibilities. Just see the previous report.
Yeah.
Okay. Great. So, but I have improved your grade and added you some points since you have fixed several of my comments. So thank you for
Thank you so much.
Okay. And the next one is another talk about some influence propagation and talk about digital transformation trends by Yatrochin.
Yeah, over here. Так. Have you seen?
Yeah. You and your colleagues from the hate speech of Russian forums are almost dying. So please wake up.
But we have energy. Let's go on. My project is this project is aiming to study a topic of digital transformation in scientific, but unfortunately, due to lack of ability to upload all the data, a lot of data, and I have for this course of project I have narrowed my course, my project into the digital transformation in healthcare. And the goal for this is to show how the area of knowledge of digital transformation in the healthcare sector works and what communities, what interests are in it. Let's go to the next slide. I have of course, to determine this subject, I collect data from the scientific database that is PubMed and Scopus, from the relevant period to the relevant language and real articles. You can see on the slide stitching methods and the total number of collected articles was more than 20,000
articles. Of course, it was a data preparation for a network analysis. It is identify authors and papers and make tuples, some work. And of course, it was extract tokens from abstract to the thematic modeling. The thematic model is LDA. For this, it is this algorithm of LDA. It was identified 20 topics by interest of the authors. I don't explain how it works because it is not this course. I will go to the network. For the network, I choose unique authors who wrote more than 2 papers. Network consists of more than 40,000 edges and all of unique authors. You can see that on this visualization of network, a big community in the center and a lot of small communities or nodes that not truly connected on periphery of this network. Of course, I want to go to the description. On this slide, you can see the description of top ranking degree neutrality and degree betweenness. And if you see this slide, it may be these results. We can claim that in one hand, these results give our understand that these authors, it's really important for our community because they not only have a lot of connection, but also connect a different group of interest. But on the other hand, it can be this reason of absent different rankings in between degree and degree centrality is possible an explanation of existing one big research group without different communities and maybe something of scholar hierarchy between authors. For clearly understanding communities in this work, I just give some method of clustering. This is a simple method of k-means, and it's based off explanation that every author is his interest from topic modeling. And of course, this communities detection was optimization by elbow methods, very simple. We have 10 communities and we can see the distribution of the clusters of our network authors through the topics of LDA. It can be really useful to understand which topic are really covered or simply evaluate the topic of modeling and just filtering a really important topic of our knowledge. Let's see to our visualization of our network by cluster algorithm. The description, of course, is the size of the node is a proportion of our co-authorships of author, and colors represent the class of author in this network. You can see the predominance of one of the classes. Of course, you can highlight this cluster and understand how many papers, how many authors include in this cluster, and from which of thematic group they fall into. Of course, on this slide, I visualize the main authors from this cluster, but it's not really informative and not really give our information about all community in our digital transformation in sphere. In healthcare. For evaluating our cluster algorithm, I use some understanding of network cluster algorithm. It is algorithmic clustering by use 10 cluster to be like our k-means clustering. And if you can see a big community in the center and a lot of not approved community on the periphery, to DB scan, it's also the same picture. If for this network, we can say that we have a predominance one large groups on entire community. Of course, if we tell about the results, it's not a good results. Our network is possible identify authors with a large connection and really important. Our comparison of cluster network and topics modeling can explain how team are more or less covered. Our limitation is data set, and of course it is one-way network co-author analysis. And of course, after your comment about core level and if about the set of kinds graph, it's a core periphery graph. I really try to update my analysis, but I just do some iteration with core level of graph. And if you can see, the more interesting it is really to increase our core level and to go inside a root community and to see how it's work and who and which communities consist. This is just some faster analysis, some faster pictures and faster algorithm. But for the future, I will go to the deeply, and of course, I will return to the to the main goal. It is a trends to some embedding models. But now that's all.
So generally, I'm very happy that this idea helped, and I guess I should Google some core periphery clustering strategies next time. But according to our seminars, the general idea is the following: you pick some core level, see what clusters do you have, take periphery clusters, remove them from the network, and increase core level and make everything again. Yeah, because usually you have different density at the center and at the periphery. And if you take the very high core level at the very beginning, you will just lose all your periphery clusters, but in fact, they have some structure. It's just more sparse. Yeah, this is the difference. So you can try to do this iteratively, and if you try to do it, it will be, I guess it will be something very similar to the island approach that we are supposed to listen at the very beginning. But so generally, this may help to find this core periphery structure after all. And of course, so I'm still hoping that you'll find some trends spreading through this community and see if there is some trend of digital transformation walking through it. This is really very promising. And since you were just the single teammate of your project, I guess I will add some bonuses to get, because others worked in large teams. Okay. So any questions, any discussions? I guess no. Okay, and do we have anyone from the Stack Overflow project? Kantimir, are you going to present?
Yeah, actually, now I can get in touch with my teammates. But I have I have a presentation. I can try and give you a brief overview of the project. Let me share the screen. One second, please. Can you see?
Yeah, great.
Okay, cool. So yeah, maybe I'll give you a bit of introduction about our project. So, you know, the Stack Overflow, this is a popular platform where thousands of users share the information about programming and other skills that they learn. So on this platform, you as a user, you can share your developer story. So this is kind of a brief representation of yourself with your skills via text. We used the data from a Kaggle to represent how technologies are connected and how they are used together. And we try to find the most popular skills that developers on Stack Overflow own. So we use two CSV files. The first one is Stack Network Links. It contains links of the network, and the second one, as you can see here, it contains nodes of the network. So this is about a dataset visualization. Next, we build a subgraph. You can see it here. So all the nodes, they are grouped by sphere of interest, like, for example, jQuery, HTML, MySQL. They belong to a group called Internet Pages, as you can see here. And so calculated degree and betweener centralities and plotted the histogram to visualize the results. The most common skills are connected to Internet pages like jQuery, HTML, and as you can see, maybe development like C# and operating systems, Linux. So this is about the degree and between centralities. So we're not able to calculate the diameter of the whole graph, but we did it for a subgraph, and its diameter was 10, and the density is the density is 0.07, and seems to be the edges, the number of edges was 490. And next, I would like to tell you about the methods. So to predict additional useful skills for a person by his text, we used an algorithm finding the shortest path using a package called path from networks X package. So our graph, it's weighted, and the weight of each edge describes its value. So the more the weight of the edge is, the more valuable is the connection. We wanted to find vertices connected with a small number of most valuable edges. And for this reason, we calculated the weight of the path with the following formula, as you can see on the slide. So as recommended skills, we presented the top 10 vertices with shortest and less weighted path per person text. And as mentioned earlier, every node belongs to some group represented by number. So we used two methods for our algorithm. This is deep and wide. These are the deep and wide modes here. So about the deep mode, it looks for new competences to learn inside the most frequent group among the results. So, and the next one is a wide mode. It looks for recommended skills from other groups in recommended list. So to implement this method, we added a threshold, which indicates if the group is frequent or not. And as a result, we got an algorithm predicting useful skills based on skill tags of a person on Stack Overflow. And I'm going to demonstrate an example of our algorithm. Okay, so I think we have missed one slide. Yeah, sorry for that. So, okay. No, we didn't include that. Okay, we can use these tables. We're gonna compare them. We're gonna compare this one and the data that is located on Stack Overflow jobs. So this is a heat map. Okay, let's look at this. So it demonstrates, yeah, the most important hard skills for developers in different spheres. And according to it, as we can see at the bottom, there is a data scientist, and it tells us that he has to be competent in programming language skills and data systems, because they share the most percentages. Like for languages, it's 56.6, and for data systems, 27.4%. So you remember that our model has recommended the junior data scientists to improve like the same skills, like we see here, like our programming language. Okay, here. The programming languages are, as we can see here, Flask, C++, MySQL for data scientists, and operating systems like Linux. We can see it here, Windows, and he must know how to work with Git. So we can see that output of our model is trustworthy. The recommendations, they are really valuable. So I think that's it for our presentation. Yeah.
Generally, so this is just some kind of the Pandora box of the recommender systems, and lots of things can be done here, starting from applying some kind of more complex models to model your nodes inside the network, and ending with some kind of path of your customer or the client that is at some exact step, and if he is at this step, then he needs these. If he is at another step, then he needs something different. Yeah, so there are lots of things that can be improved, and in fact, recommendation systems is just some kind of hot topic at all artificial intelligence conference right now, and you can find lots of different ideas in terms of the improvement. Generally, it looks, so I may be wrong, but it looks like you have done many things for the second control point, but then something just made you a bit stop, or at least work less intense, and looks like so many things can be improved. But so generally, this is still a nice project, and yeah, I have corrected your grades. I guess I can even give you 9 for the presentation, just for your efforts. And so this is the general feedback.
Okay, thank you so much. Yeah, I totally agree with you. It can be improved in many ways. Actually, 1-2 years ago, I was in machine learning, and I used some ranging methods, classification methods. I even have my own application on App Store and Google Play. The mobile application, they used some methods. One of them was a classifier method for predicting which position you would take on the pitch if you are a football player, like whether you are a forward or a midfielder or defender, based on your scores. I mean, your speed, your strength, like yeah. So yeah, I agree with you. It can be improved. Yeah, but as an example, I think.
Okay, but so this is still the result of the project. So thank you very much. And by the way, continue. What about your tests? It looks like you haven't passed at least one. There is some mistake.
No, actually, I didn't pass it. Yeah, I wrote you about it. Yeah, you remember there was some problem.
Yeah, but okay. Okay, so we will discuss it separately. I need to see what I told you, because yeah, lots of students. This is a bit messy. So can you please highlight it for me inside the Telegram chat, and I will just take this into account when I put the final grade for you. Okay.
Sure. Okay. Thanks.
Okay. So thank you for coming. Ilya, Maxim, thank you for listening to the very end of our small conference. And thank you for visiting the course. I guess it was interesting and useful, and you have learned something from it. So I guess we can end up with our course defense section.
Thank you.
Yeah. See you. Bye.
Bye.